Hello. So hi everyone, कैसे हैं आप सभी लोग? Hopefully you all are. I think am I properly audible to everyone, guys? Am I audible? Actually, because of this technical issue, we couldn't start it on time. We are like 5-10 minutes late. But anyways, okay. Hello, 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 hello. So I think now it is perfectly audible to everyone. So I think now it is perfectly audible to everyone. So I think now it is perfectly audible to everyone. Correct. So duration will be the same. Will take around 4 to 5 hours. It's a huge chapter. So welcome everyone. How are you all? I hope every one of you is doing absolutely fantastic. This is your chemistry expert Sanjay Arya sir, and today we'll deal with a very important topic, very important chapter from organic chemistry. We have aldehyde ketone carboxylic acid, which is considered as the biggest chapter. Like so many concepts are there involved, so many questions have been asked previously, and it contains high weightage of the chapter. So what are we gonna to do? We have three compounds, aldehyde and ketone. Probably we'll deal with these two compounds today, and we will conduct this for another lecture of carboxylic acid and its derivative, because along with aldehyde and ketone, it's a huge chapter. The sequence or the flow will be the same. First, we'll cover the introductory part. Then we have preparations of these compound, physical and chemical properties. Chemical properties involves the chemical reactions, and over 100 plus practice question we'll do in this session. So this is your JEE PYQs. So let's start the session. First of all, let us take the introduction. What are carbonyl compounds? So guys, we collectively call them, whether there is an aldehyde, whether there is a ketone, or it is a carboxylic acid, these all are collectively called as carbonyl compounds. So guys, carbonyl means a group is there. This group is called as carbonyl group. So whatever the compound is there, organic compound which involves this group, is considered as a carbonyl compound, right? We have aldehyde and ketone specifically, which two are functional isomers of each other. These two are functional isomers to each other. Why is it so? Because one of them can exist as non-terminal carbonyl group, and another one can exist into terminal carbonyl group. This is actually terminal. What do you see? This is terminal. If terminal group is there at the end of the chain, it is coming. We consider this part as an aldehyde. The another part, which is called as ketone, will definitely be having this carbonyl group in non-terminal position. So that is what the difference between aldehyde and ketone is. Aldehyde, ketones. So these two are functional isomers to each other. So this is some basic introduction. We already have the clue about what aldehydes and ketones are. We already have covered our GOC chapter and already have taken the idea about these two. Then we come to their IUPAC nomenclature, which is again very easy part of this chapter, and we already have covered this part in our GOC chapter itself. We have this compound given to us. So always make sure that aldehydes are the principal functional group, and they also contain the carbon atom in it. So this carbon will be considered as a part of main chain. 1, 2, 3, 4, 5, 6, and 7. So once principal functional group has given the first priority, we don't have to think about the possibilities for substituent. Like a substituent may get anything, but principal functional group must get the first priority. So we have bromo and we have methyl, no doubt. So we'll write it 4 bromo, 4 bromo, 3 methyl, no unsaturation, heptate, you can one null or you can simply say heptanal. So this is heptanal, right? Similarly, this is another aldehyde group. We have 1, 2, 3, 4 are very easy method, pro-but. So this will become butane 1-ul or butane-ul also can be said. Ul we use in the terms of aldehydes. So now talking to the ketonic part if we have, okay, let me just take you to one good example here while going for the same. Let us suppose this is a example. We have an aldehyde group, we have a ketonic group also. Similarly, there is a question in which only, let us suppose these two are some examples and we got to write down their names. The priority will be given as per the order of functional groups. I told you in IUPAC nomenclature that aldehyde gets more priority than your ketonic group. So this will become the principal functional group, and now this group becomes what? Substituent. So the correct name will be methylprobute, and 3 contains oxo, or you can also write keto. So 3 oxo methylprobute, butane 1-ul. This will definitely be coming 1-ul only, because we know that this is a terminal group, and if it is working as a principal functional group, it will definitely be getting first position and first numbering. Now coming to this part, this OH group will become a functional group with respect of ketonic group. So we will give, okay, we got hydroxide here at second position, but 1, 2, 3, 3 at the principal functional group. But doing this, we are getting our principal functional group at most prior positions. Lowest locant rule says that. So this is your principal functional group part. You got to name it like methylprobute. Instead of write that 3 hydroxy butane butane 2 on, butane on or butane 2 on. So that's how we write it, guys. Hopefully this is absolutely clear to all of you. Right. We have a question, everyone. Let's see who can try this question. General formula of carbonyl compound. So generally, whenever we say carbonyl compound, we talk about aldehyde and ketone. We talk about aldehyde plus ketones in general, because these are the compounds which contain only carbonyl part, C double bond, not other than that. Carboxylic acid might contain C double bond and OH also. That can show different type of property based upon the functional group it has. So aldehyde and ketone has general formula what? So guys, the formula will, they all have degree of unsaturation as 1. So remember the formula, they will be having CN, H2 and O. Remember this part. And undoubtedly this cannot be the formula, because one oxygen at least should be there. So remember this part. We have a question of naming itself. We also have done this part earlier. We all know that this hydroxide will be considered as a substituent only, because the main functional group will be this. This is called as PFG, principal functional group. Everything will become everything else will become substituent. So 1, 2, 3 and 1, 2, 3. It is coming on 3 only. We are getting one hydroxide here and one methyl group here. I think this is the better naming. This is correct. 1, 2, 3, 4, 5. Why? Because at 1 only we are getting the substituent, and starting from here at 2 we are getting first substituent, and the position of C double bond O is same in going either direction. So we'll do it. 1 hydroxy, 4 methyl, pentane 3 on, pentane 3 on. So 1 hydroxy, I guess A is correct answer. So these are some simple questions, but believe me, such kind of questions have been asked previously in your exam, and especially in the JEE main point of view, it's pretty important. Okay, so always stay focused while solving the problem and giving the IUPAC name. Although this part was already covered in GOC, so it's not very tough part to you. It's very easy to do the IUPAC nomenclature. I told you in the whole one lecture, so you must remember this part. And guys, we right now are basically we have held this all India mock test AIMT for IIT 2025 people, and we right now are doing it on free of cost, guys. So just it's starting from December 22nd, so we still have 1 or 2 couple of days to enroll, and it's completely free enrollment, guys. Go now and just enroll it. So what you are getting right now in it, you will be getting the real exam simulation for JEE Main 2025. So many people across your country will be giving this exam. This exam will help you to identify yourself, where do you stand right now, where you can go from here, and this is most important part of this. Then we will having questions, perfect questions from the best of the faculties available in India. Predict your rank after the test. Now, as usual, we already have discussed the flow of the chapter, and the flow of chapter works in such a way that we first of all we have the introductory part. Right after that, we reach to the preparation. So preparing of aldehyde and ketone is our now target. So aldehyde and ketone, which are collectively called as the carbonyl compounds. Now carbonyl compound will be prepared using so many preparation method. Very first of them is called as preparation of aldehyde and ketone by hydrocarbons, from hydrocarbon. Now hydrocarbon could be alkane, alkenes and alkyne. And alkenes, we all know that alkane can reach to carboxylic acid in extensive oxidation. In normal conditions, using copper and 500 Kelvin temperature, it can reach to alcohol. So we are gonna to do a controlled oxidation that will take us to the preparation of aldehydes or ketone. Then alkenes can undergo so many processes: oxo process, Waker's process, oxidation process. So many things are there that produces aldehyde and ketone. And then alkynes will also be giving the similar kind of reaction given by alkene in a double way. So let us come to the first reaction that we already have covered in previous some chapters. Majority of these reactions will match from hydrocarbon chapter, because in hydrocarbon we have studied all chemical reactions for alkane, alkene, alkyne. That is exactly replicated over here. We have first reaction by controlled oxidation. Guys, you must remember that heating a tertiary, a 3 degree like not 3 degree or like any alkane specifically, or especially as 3 degree hydrogen containing alkane, and that reacts with copper in presence of some heat and it produces alcohol. Then the reaction with oxygen in presence of molybdenum oxide, this is MOO, and at 200 degrees Celsius, and this it produces HCHO. So we will simply learn this reaction. It's one of the important reactions. Just take this thing in your mind. Anywhere it can be reflected in your exam in one of the particular step. If methane or any kind of alkane is given along with molybdenum oxide, you got to prepare this aldehyde as a product. The very next we have reduction of ozonolysis of alkene. Reductive ozonolysis has already been completed by us. The simplest formula to learn about it is like wherever the alkene is given to you, and if you need to do, if O3 is given to you in some polar or partial polar solvent such as CH3 chloroform, CH2Cl2 or CCl4, and thereafter after it we are using either zinc dust, or somewhere we can also use Me2S, dimethyl sulfide. So guys, so what we are gonna do, we'll simply break this bond like this, and right after breaking the bond, make this compound. Now you believe me, if these two groups are alkyl, it will give you a ketone. If either one of them is hydrogen, it will give you an aldehyde as the product. It's very easy reaction. So let's come back and solve some problems here. We have one question. Okay, then that is it. Alkene with reaction of reductive ozonolysis of alkene is completed over here. Now we'll reach to the third reaction, which is oxidation of alkenes. Oxidation of alkenes can be done using two different solutions. One of them is called as Bayer's reagent called dilute KMnO4 that produces vicinal diol. So I guess that reaction is not of our use, but this reaction, oxidation of alkene with acidified KMnO4. Acidified KMnO4 is a strong oxidizing agent. So this is something very good. And what does it do, by the way? It not just gives you double bond O on breaking this bond, but it also provides, if any hydrogen is there, that will be converted down into OH group. Let me take you to one example, everyone. Let us suppose this alkene has one hydrogen here, one CH3 over here, one CH3 over here, and one CH3 over here. And what we are using is acidified KMnO4, potassium permanganate, a strong oxidizing agent. This oxidizing agent not just breaks this bond, it breaks it and converts into O. And along with that, if any of the hydrogen is present here, that will be converted into OH. So this will be converted into OH and then CH3. So what we are getting is, one of them is carboxylic acid. Now another example could be, let us suppose this is another such example where CH3 there, and let us suppose where we are having two hydrogen over here, and a similar reagent will be used as an oxidizing cleavage, and then what we are getting will be, one of them will be CH3. This will be an acetone, but right after that OH will be 2OH. So 2OH will eliminate out water and will form what? So initially it will give you C double bond O, OH and OH, and we know this is highly unstable. So it will eliminate out water and then it will form what? Carbon dioxide as the final product. So what we are getting is carbon dioxide as the final product. When we'll be getting carbon dioxide? When the doubly bonded carbon itself contains two hydrogen atom over it, then it will be getting converted into CO2 gas, final product. We are not worried about these reactions. We already have covered this part in hydrocarbon chapter. So we can move ahead easily. We can solve some more problems. We can reach out to some new processes. One of them is called as Waker's process. The Waker process, first of all, we must know what reagents are, what is the substrate, and what will be the product. So guys, this kind of reaction is highly important to all of us. We are not supposed to learn down its mechanism, because this reaction, if comes in the examination, will come directly. There is no manipulations can be done on this reaction, and that's what I suggest to all of the people right now whoever is studying organic chemistry with me. I would like to give you one suggestion, that never go for mechanisms of all the reaction. Go for only those mechanisms for which manipulations of the reagent or substrate can be done, and can be the further compound can be asked. These reactions could be rearrangement of carbocation. These reactions could be Markovnikovs, anti-Markovnikovs, hydration, oxidation, electrophilic addition, or nucleophilic substitution. These reactions may involve so many reaction mechanism involved in it, but right after that we have plenty of naming reaction, plenty of those reaction for which simply make the short notes. And this is a message for all JEE 2025 people, that simply make your short notes, write down the reaction. You must know the substrate, attacking reagent, and final product. If you can do this, you will definitely get best of your marks in organic chemistry. Come back to our topic, Waker's process. What is it? Yes, sure, I'll do that. Thank you, SP. So we have Waker's process. What does Waker process say? That alkenes can directly be oxidized into corresponding aldehyde or ketone by treating them with a solution of palladium chloride and containing a catalytic amount of cupric chloride in presence of air. So simply the reaction will be, we have an alkene, water PdCl2, CuCl2 and air will be given, and this will be converting one of your hydrogen into CHO. But always remember, like you want to ask me the shortcut to remember this reaction, it provides OH group to like a Markovnikov's addition kind of thing happens, and in order to just remember this reaction, we simply say that this will acquire a OH group and this will acquire a hydrogen, so this will become CH3 like this. And now we all know that two hydroxyl groups are unstable on one carbon atom, one will be eliminated out, forming RC double bond ON CH3. So this is how you can remember the reaction, that under Waker's process, any doubly bonded carbon which is more surrounded by the groups will be acquiring two OH groups, and that will be converted into C double bond O. Then The next is called as oxo process, also called as carbonylation. So guys, just read it about it and allow me a moment. I'll be sure to come back and join you in 2 minutes. Got some important work to attend. Yeah, everyone. So we have another process called as oxo. Oxo is your carbonyl group only C double bond O part. So insertion of that part comes under this category. I would like to give you two important reactions throughout of it. This process contains two important parts. Uh, if the same reaction we carry out in the presence of carbon monoxide plus water and heat, and no doubt this cobalt tetracarbonyl is working as a catalyst promoting the reaction, this will give you COOH and will be simply CH3, right? And the same reaction happens here also. So what we basically get, we reach to an electrophile like this, and this electrophile basically attacks on the doubly bonded carbon. The next to it will be acquiring a positive charge, sorry, H, and that will give you this reaction. So one extra carbon comes in this reaction, and both of the products we are getting as the output, but electrophilic addition on the more substituted, like the giving the formation of a what should I call it? More stable positive charge will give you the major product. So I guess in that way we will be getting this as the major product, right? This is called as oxo process. Addition of carbonyl takes place here. So guys, remember these reactions. Try note down all the reactions and then you'll be comfortable writing what reagent gives you what reaction kind of. We have acid catalyzed hydration, and we also call it like Kuchereau's reaction. And I already have explained this part earlier in hydrocarbon. We'll explain you one more time here. We have any alkene. Let us suppose this is one of the alkene, and let's say this is having a CH3 and this is having just H. In order to explain like what happens in the case of unsymmetric alkene. So guys, wherever we are given with dilute HgSO4 or H2SO4, we have been given up with, and simply do the Markovnikov's addition of, simply do the Markovnikov's addition of HOH. So H with positive charge, OH with negative charge. So what will happen? We all know the product. This will give you CH. This will acquire more hydrogen, CH2 double bond. We have one OH group here and then CH3. This is Markovnikov's addition only, simply Markovnikov's. So this is called as enol form. Enol form is not so stable. It will reach out to the keto form and it will tautomerize meanwhile. The tautomerized product will be CH3, C double bond O, CH3. The acetone is your final product and this will stay as major quantity. And that's how you can prepare whatever you want. So we have created here a ketone, and similarly we could have created an aldehyde also. If both of them will be terminal, we can produce an aldehyde also. This reaction is already covered by us in hydrocarbon chapter, but still we have this idea. And always try to reach out to the reaction in your own way. You try to make some imaginations how the reaction would occur, what could be the fastest way to learn down this reaction. Like I already have made it. The reaction mechanism involves the attack of Hg2 plus ion over here, where this will form a cyclic cation. But the problem is writing that reaction, and that will acquire a lot of time and everything. That bestest part should be learning down the hacks, and this was one of the hack. Just simply do the Markovnikov's addition, tautomerize it. The next reaction is called as hydroboration oxidation reaction, where another such thing will happen. And so let us suppose the same reaction has been taking place over here, and we have this compound with us, and this compound on reaction with B2H6 THF and then hydroboration oxidation. So guys, always remember, like in this step what we have to do is be smart, simply take the initiatives that in this reaction only the hydration is taking place. Markovnikov's will become anti-Markovnikov's here. So this is your anti-Markovnikov's addition, and I already have explained its mechanism, that how B2H6 comes and cover up this molecule and makes a cyclic 4-member transition state, and then transition state reaches to the formation of like the addition of HH somewhere, and at last OH group attacks at the final stage, and where anti-Markovnikov's addition takes place. So addition of H plus and OH minus will take place. So now I'll do it and then you'll be getting the final product. Now let's see how does it work. This compound CH triple bond, this is CH 1 OH double bond C, we have just 1 H and then CH3. So right after this reaction what will happen? This is another keto form. This will go for tautomerize, tauto, and then tautomerization will lead to the formation of hydrogen will go here, and C will go there, and this will become CH, CHO, aldehyde we are getting, isn't it? CHO, CH2, CH3, propanol. We are getting now an aldehyde, not ketone. Chalo. Now let's try one question. So how many double bonds are there in hydrocarbon, which upon ozonolysis gives a mixture of acetone, aldehyde and glycol? This is some typical question I find. So one of the product is acetone, acetaldehyde, and glyoxal. Oh, what is it? Maybe this is glyoxal. So how many double bond does it contain? It has been asked. So I guess 2 double bond it must cover. What do you think? If it's the same compound coming out of it, so I guess like adding two double bonds, adding 2 double bond O and making a cyclic ring. So I guess this should be the compound. C. No, let's not make it the ring. Simply make the compound like this. This will be having 2 CH3 group. This is having just 1 CH3 group. So this is giving you acetaldehyde, this is giving you acetone, and this will be giving you the one we are looking for. How many double bonds can you find here? The answer should be 2. Yeah, hi everyone, hi guys, hi, hello, time is over everyone. So I would expect some answers from you. Please reply me and give me the answer. And guys, now you people might be pretty much confident. It's been now over a couple of months we have started our organic chemistry and we are doing well. So we are right now on the edge of finishing the entire organic chemistry. So I would expect from you people that whenever it comes any doubt in your mind, do ask me. Whenever I asked you some question, please respond me, so that you will not just become confident about the concept, but also there will be like a proper conversation going on between us, interaction will be going between us, and that actually helps teachers to stay motivated throughout the lecture. We have a question here. So find the product of the reaction. Now you need to find out the final product of this reaction and take your time and then give me the correct answer. So KMnO4, and we have covered this part here. Alkaline KMnO4 and heating, strong oxidizing agent. So this will give you CH3 double bond O. Then coming to this part, we have one hydrogen that will be converted into OH and then it will be converted into COH. Not COH, means simply O double bond OOH. So we have we have one carboxylic acid group, another one is ketonic group. That is the reaction is all about. Another question: which of the following gives acetone on ozonolysis? Whenever anything is not mentioned, we always consider it as a reductive. Whenever anything is not mentioned, we will consider it as a reductive ozonolysis. And also oxidative ozonolysis do not produce carbonyl compound. Instead, it gives you mainly or majorly carboxylic acid group. So compound which gives you acetone on ozonolysis. So this will give you what? It gives you 2 acetaldehyde. This will give you 2 acetones. This gives you 1 benzaldehyde, 1 formaldehyde, and this gives you 1 formaldehyde, 1 acetaldehyde. So correct answer should be B. Gives acetone. So only acetone will be produced in B option. We have another question that ozonolysis is done first and that too reductive. So from where we can get this only one product? So definitely there will be like 2 molecules of this compound will be given to us, because you know what, a double bond has to be broken down. If a double bond is breaking down, definitely 2 products will be formed. Now there's a possibility that these 2 products are the same. So if these 2 products are the same, in that way we'll be having this kind of compound will be there. Yeah. So this one will give you this what reductive ozonolysis. A. We have one question that was asked in JEE Main 2022. Let's see who can give me this correct answer. It seems a bit typical question here. So we are being given with a compound A on a reaction with X and Y. So now we don't know what is X and Y, and then it produces the same major product but different byproduct A and B. Okay. Okay, one of the product is the same, another is different. So what could be the possible number of reagents? So what do you think? So I'll give you the idea. Let us suppose if we go for now I've got the perfect answer here. I have got the perfect answer here. We have different product, and A gives produced by ends. Oxidation of A gives substance produced by ends. Okay, got it now. So guys, the substance which is produced by ends will be produced by ends is actually HCOH, formic acid. So whose oxidation produces formic acid? HCHO. So A will definitely be, A is definitely your A is definitely our ozonolysis. We are doing reductive ozonolysis because A can also be oxidized, no? So this will give you HCHO, and this upon oxidation can produce formic acid. So I think this is the correct answer. First should be the ozonolysis. Incorrect. This is correct. First is ozonolysis, and second one is directly converting into this will give you, no doubt, this B will be simply CO2, direct final oxidation product using KMnO4H positive. So D is the correct answer. I also checked a few more options, but I couldn't find any of the option in which this CH2 part on oxidative cleavage, this part on oxidative cleavage can give you formaldehyde, and formaldehyde, if it is not there, definitely it could be reductive ozonolysis. Otherwise, all these oxidizing agents and on oxidative cleavage or double bond will produce you directly either to CO2 or directly to the formic acid. So that will not give you formic acid on oxidation. So correct answer should be D. D is the perfect answer. See, we got +4. Yeah. Next is preparation from alkyl halide. Now, till now we have covered the preparation part from hydrocarbon. Now coming to the preparation from alkyl halide. So you all know about alkyl halide. Alkyl halides are RX. We can do hydrolysis of geminal dihalide. Geminal means if the same carbon atom possesses two halogen atoms, it is called as geminal dihalide. Geminal diol, geminal di, anything. So anything will be like two atoms or group of things will be present over that one carbon atom. We have 2Cl over here. This is geminal term, geminal halide, and on this will undergo like some SN2 reaction. So under SN2 reaction, this will give you simply two products, OH, and then two OH are unstable, you all know. Then water will be eliminated out of it, and then it gives you acetaldehyde. The similar reaction over here for non-terminal, so that will give you ketone. So aldehydes will be produced by terminal geminal dihalide, and ketonic product will be produced by non-terminal dihalide. Next is oxidation of alcohol. So guys, oxidation of alcohol is actually done under two things. We'll try to learn some of the mild oxidizing agent first. So we have plenty of things here. Let me take you to the idea. that guys 1 degree alcohol on oxidation gives you aldehyde, and this upon further oxidation gives you carboxylic acid. If you have a 2 degree alcohol, it may undergo oxidation, lead you to the formation of ketone. Now this upon further oxidation gives no reaction. And the similar way, we have a tertiary or 3 degree alcohol, and usually 3 degree alcohol on oxidizing agent gives no reaction. Upon harsh conditions, it may go for elimination reaction if you are using copper, and then it works as a dehydrogenating agent. So that's what we are expecting, and this could be in a strong and weak also. So if it is a strong, so this is like weak oxidizing agent. If we are using a strong oxidizing agent, it will not stop in aldehyde. In the presence of strong oxidizing agent, this will be directly go to the carbonyl. This could be weak or strong, anything you can prefer, and that 3 degree can also be weak or strong. It will not be oxidized anyhow, so it won't go. Now talking about some of the important oxidizing agent, we have some mild oxidizing agents here, everyone. Some mild oxidizing agents we are talking about. Mild means they are weak oxidizing agent. They are selectively oxidizing a compound like 1 degree alcohol to aldehyde, not directly to the carboxylic acid. First of them is called as PCC, which is very important reagent. Somewhere you will find in your exam written PCC. That means it is doing the partial or a weak oxidizing agent is present there. This is called as pyridinium chlorochromate, PCC. The structure somehow look like we have pyridine, we have HCl, and we have CrO3. So the reaction in non-aqueous solvent happens, and there it produces a compound ammonium chloride, this pyridinium chloride plus CrO3. This is called as pyridinium chlorochromate. The another example, similar example is pyridinium dichromate, which is Cr2O7, and this pyridinium anion is C5H5NH. We have Collins reagent. Collins reagent is chromium 6 oxide Cr2O3 with pyridinium in dichloromethane. So similarly we have another Jones reagent, but Jones reagent can be considered as a strong oxidizing agent. CrO3 plus dilute sulfuric acid. Now we will go to some of the reactions with mild oxidizing agent. As I told you, what do you think it? It's a primary alcohol. Primary alcohol on reaction gives you an aldehyde with mild oxidizing agent using these three. See, I'm not using this part, right? The fourth one in dilute sulfuric acid is strong oxidizing agent. So what we are doing is using this neutral medium used in mild oxidizing agent. Okay, and mild oxidizing agent such as this 2 degree will be converted into ketone, and 3 degree doesn't give any reaction. Now coming to strong oxidizing agent, these are some set of strong oxidizing agent. The best part about my notes is these are very much self-explanatory note. I make my notes in such a way that even if a student revises in absence of a teacher, by the time of revision you'll get all the concept, because everything is very much clearly written on my every slide. So download the notes from the link given in our description of our Telegram channel, from where you can collect our notes. So guys, do subscribe to us on Telegram as well as channel. Join our channel, subscribe to this channel for your updated videos and lectures coming like before your JEE exam. And also one more thing, that we also are launching that event called as All India mock test. Do it, give it, and so that you can get the idea where you exactly stand and where you can reach from here. So these set of reagents are called as strong oxidizing agent, and they react with producing the carboxylic acid. Strong directly leads to primary alcohol to carboxylic, and then this will be going to ketone, because ketone cannot be further oxidized. Ketones, whether it is like a strong oxidizing agent or a weak oxidizing agent, it doesn't give any further reaction, and tertiary are not oxidized. But if you treat a tertiary with copper, which works, copper and heat works as an oxidizing agent, everyone. So copper under around 573 Kelvin temperature, it leads you the formation of so aldehyde, ketone, but this doesn't undergo, it goes dehydrogenation, not dehydration. Okay, dehydration occurs, and elsewhere dehydrogenation was occurring, H2 was leaving out, here H2 is leaving out, forming alkene as a major product. So just take the idea where the reactions are working, what products we are getting, and since this part has been already covered in hydrocarbon chapter, so we don't have any as such problem understanding the concept. Then we have oxidation with very strong oxidizing agent. So very strong oxidizing agent can also oxidize ketones, and no doubt very oxidizing agent will create an alkene also, and that alkene can be oxidized for the further processes and further basically compounds. Check it out, these reactions, and if you face any doubt, I'll explain the part. Wherever you face any doubt, I'll explain this part. Okay, so let us suppose this is a ketone we have. So this is a ketone we have, and so we have to basically oxidize it using KMnO4, and we are also providing it heat. So this is the strongest oxidizing agent, along with this drastic conditions of heat will definitely work out. And whatever the whatever the bond you break, so this will be broken down because this C double bond O, this stays with smaller alkyl group, and the oxidizing cleavage or oxidation of a ketone is basically covered under the part of called as Popoff's rule. So Popoff's rule is this, that C double bond O group remains with the lighter part. So let's say this carbon is carbon C13. So this reaction will happen in such a way that carbon will C13 will acquire this C double bond O group, or let us suppose this carbon is C13 or this is C13. So this will become CH3, C13 double bond O, and then OH, plus the another will also be converted into C3, C2. So anyways, there is no as such huge gap over here, but I'm just explaining that C13 will group go to the lighter one. This is called as Popoff's rule, and this comes under oxidizing cleavage or oxidation of the ketones. Next is preparation of diol. Preparation of diol. What is preparation of diol here? Okay. So oxidative cleavage of vicinal diol, preparation from diol. So what we are doing is we are introducing the HiO4, which is not just a oxidizing agent, but it also, hello, yes, yes. Fuck off, yeah. Yeah, now come back. So diol we are doing. So guys, we already have come across this reaction, and I must say this is called as periodic acid is the reagent which gives you the oxidizing cleavage, and the cleavage happens in such a way. Let us suppose this compound, this carbon has OH group, and this is another OH group, and let whatsoever is present over here. So this in the presence of HiO4. Just simply learn this reaction. We already have covered the mechanism in the previous sessions, but not required. I would again suggest not required, but just always think that it works in a cyclic transition state where these two should be in syn position in the similar direction, and the presence of HiO4 will break down this bond in such a way that it will introduce one more OH group. So this gives you OH and this OH plus this is your OH and OH. So guys, wherever so this is not stable, so the final product will be two water molecules are eliminated out, and they will give you C double bond O and two equivalents of this. Next thing could be, let us suppose where we are having a C double bond O and COH. So there what we are gonna to do, so just assume this compound as, this can also be assumed, this is your COH, OH, and like this. So this compound on oxidation or oxidative cleavage by HiO4 per iodic acid will give you what? This will be broken down, then this will become C double bond O, OH carboxylic acid, and then another will become what? C double bond O, like this. So this is how we do the oxidative cleavage. Please remember this reaction, it is very important. This is how the working of HiO4 takes place. Per iodic acid works like this, shown here. No, 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 no. Now try some questions. All the preparation part are done. From hydrocarbon, from RX, from alcohol. Now let us solve some question and we'll move to the next part of this chapter. First thing is, for the given reaction, the option wrong one is. So guys, X will be what? We know this reaction after enolization. This will give you this ketone. This is the final product, X. X is undergoing attack of methyl magnesium bromide. This attacks nucleophilically or producing what? CH3. One more CH3 will be attached here. Then this will become OH and then it will become H. This is a 2-degree alcohol. 2-degree alcohol on reaction with K2Cr27 will give you acetone as the final product. Now check it out, the correct product. Z is this? Yes, Z is this. Is X this? Yes, X is this. Is Y this? This is this. I think, what is this here? Everything is correct. Which is wrong? Okay. So the only incorrect is this. Now solve this question, everyone. Now assume this thing, that CH2OH, we have COH, we have COH, that's it. So how does this work? I told you this will be broken down and OH bonds will be produced. So this, wherever it breaks from, it will give you OH group. So the correct product will be, this one is CH2OH. On breaking, it will give you what? CH2OH. This is OH. This is another OH. Removes water. The final product will be. So this is like two CH2OH are there. So this will be like 2H2O will be eliminated out, and this will give us 2 HC double bond OH. Then the middle part, this is what? Already COH is there. What is it give? What does it give? Minus 2H2, and it will simply produce CO2 gas. Now coming to these two part, that will give you 2 HCOHOH and one more OH, one direction. HCOH. So that is the final product you'll get. That's the product we are getting. I think we have missed one, so not a problem. So how many of these will be formed? This 1, 2, 3 will be the similar. This is the final outcome of this compound. Now let us move to some questions of the similar concept. We have, which of the following reaction of ketone is formed? In which ketone is formed? Okay, here we will be getting this as product CH3, CH2, not CH2, COH. This is the product. Copper and heat to second degree will give you dehydrogenating product, and in this reaction alkene will be the major product. In which of the following reaction ketone? So ketone is formed in 2 degrees. So 2 degrees, this C is the correct answer. So this is how we have to apply our mind whenever these questions are given to you. Try solving all of them by yourself. Stay confident and bring your confidence. And that is the only way of remembering all of these reactions, that you must know what reagent is there, what attacking reagent is there, what is substrate, and what will be the product. And that's what it is needed in entire chemistry. Now coming to some of the reactions are there for which the mechanism is highly important. There we will explain all the mechanism part. We have by dry distillation. I already explained this part even in your previous lecture. So by dry distillation of calcium salts of carboxylic acid, you can produce the aldehyde and ketone. One of the decarboxylation reaction is here. So guys, this is how we do. Let's suppose we have this is how it look like. So guys, this is how it is like separated out in the form of calcium carbonate will be removed out. It's a one-step cyclic mechanism, but we don't need to remember the mechanism, just remember the output. This is how it is removed, and the remaining one will be connected like this, C-O-H. This is your product. So in the way, if we are getting more than one calcium salts, multiple products can be formed. That mixed product can also be formed, and similar product can also be formed. So it will give you R C double bond OH, R C double bond O R, H C double bond O H, R C double bond O H. All of them will be the product. Mixture of products. And always lighter will be the major, because this mainly follows a more or less like this reaction follows free radical mechanism. So that's why more stable free radical will give you the major product, and radical with, sorry, the heavier radical will be more stable, I guess. R radical. So now next is on passing the vapors of fatty acids over manganese oxide, one of the another reaction where we are preparing our carbonyl compounds from carboxylic acid. So we have as this RCOH, normal general carboxylic acid, reaction with manganese oxide at 300 degrees Celsius forms ketone plus CO2 plus H2. So what is the difference in this reaction, the previous one? Okay, so two equivalents we are using. Manganese oxide, and then we are heating it at 300 degrees Celsius. Then this gives you R C double bond O R, and CO2 and H2 are removed. So that is how it works. Another free radical mechanism I can see. So if we have a mixture of acids here, mixture of acids as in like now we are using only one RCOH. If it could be like R1COH and R2COH, then we can get the multiple products. We can get the product in RC denoted R dash. Unsymmetric ketone can also be prepared. Fourth is Rosenman reaction, one of the very important reaction, and that is actually prepared by like using palladized barium sulfate or barium sulfate, including this. And apart from this BaSO4, we can also use sulfur or quinoline. So these two reagents or these reagents work as poison to decrease activity of palladium. So guys, in the presence of palladium, it will reduce it and it will get converted into RCOH. Let us suppose if we are not poisoning it, then what will happen? This could have also reduced down to RCH2OH, which is not our desired product. Our desired product is preparation of the aldehyde. So this reaction specifically is used for preparation of aldehyde. We use this BaSO4 and PD, which is called as Lindlar catalyst, and we do not go up to alcohol because we are poisoning the palladium part, catalyzing part, by sulfur or quinoline or PaSO4 or even calcium carbonate. So that is what this reaction occurs. Very important reaction, and it's since it's a naming reaction, I must ask you to learn down this reaction. Very important, Rosenman reaction. But only aldehydes are created here. We also have another important reaction where we are using R2CD, dialkyl cadmium. So dialkyl cadmium is actually less polar. And that's why the reaction stops here, right? But if in the same way we use, let's say RMGX, R-MGX. So first it will go attack over here, will be giving you R COMGX, and then Cl will be removed out, and then it will become C dash. It will become again but then another product RMGX can also attack and can give you R as a final product. The same is not possible in the case of dialkyl cadmium. So that is why dialkyl cadmium being less polar, it reduces up to here, and then further attack is not possible, or we can say no further attack. R2CD, no further reaction. So it is a very important part I'm explaining right now, that this reaction could have taken place even with another organometallic compound, a very good resource of OH minus, R minus, which is your Grignard. But Grignard being more polar in nature, more attacking in nature, more pre-ready-made alkyl anion is there which can attack nucleophilically and can produce you to further final preparation of alcohol. But this will stop the reaction up to here. That's why we use dial alkyl cadmium rather than using RMGX. So it's a very important one. I explain you. Next is, if we are bringing and we are producing our this carbonyl compound from carboxylic acid and its derivatives. So its derivatives are what? Actually, let me just give you an idea, but we'll cover this part in our next chapter, carboxylic acids. Specifically, I'll deal with carboxylic acids. If something is like this, this is called as carboxylic acid. Carboxylic. So guys, if we are producing a group G and we are removing this OH part, then this is called as derivative of carboxylic acid. This could be RC double bond O X acid halide. Now X could be chloride, fluoride, bromide, jo bhi hai. Then if it is substituted by OR dash, it becomes ester. If it is substituted by, it becomes acid anhydride. It is replaced by this, it becomes amide. And believe me, RC triple bond N is also one of them. We call it nitriles or cyanide. Cyanides are also the derivative of carboxylic acid. And a very simple definition says that if you go for hydrolysis of these all compound, it will give you carboxylic acid only. So take this example, take this idea, and probably in our next class I'll explain complete carboxylic acid, where you will get all of these reactions fit together. Anyways, now we have another question here. Another reaction says that we are going to bring Friedel-Crafts alkylation reaction, acylation. Actually we are doing what? Friedel-Crafts acylation. So whatever the compound is given to you, CH3C double bond O Cl on reaction with anhydrous AlCl3, it forms CH3C double bond O positive cation, which is actually resonance stabilized. So don't worry that how come doubly bonded carbon is acquiring positive charge. It will. And then reaction, whatever the reaction we are having, let us suppose benzene we are bringing, and we are having this cation with us. Then electrophilic aromatic substitution occurs, and then your final product will be this is ketone, and this is called as acetophenone. So that's how its mechanism works, or this is how we produce the final product. And this could be variation of the compound, like if you are bringing C6H5COCl, then benzophenone will be formed as a product. This was acetophenone. Another benzophenone can be formed like this. Preparation from cyanide. So cyanides, we all know what cyanides are. C triple bond N. One of the method could be their simple reduction with dibyl H, which is called as diisobutyl aluminum hydride, and it's a very good and it's a selective reducing agent. Why am I calling it a selective reducing agent? Because it doesn't reduce everything, but whoever it reduces, it stops somewhere, and where by hydrolysis we can produce. Getting me? So this is like ester is given to you. So now ester on dibyl H and hydrolysis, R C H will be connected here. Aldehyde will be produced, and byproduct will be this R dash OH. This is your byproduct. Similarly, over here we have nitrile. So initially we are bringing dibyl H, that will be bringing this compound into. So dibyl H selectively works upon dibyl H, diisobutyl aluminum dibyl H. So dibyl H simply reacts with this, giving a reduced product like this, and this reduced product under hydrolysis produces R C double bond O H plus NH3 will be eliminated out. This is how it works. So using this dibyl H, we have a reaction, diisobutyl aluminum hydride. Hydrogen donor selectively works upon aldehyde and sorry, it only works, dibyl H only works upon esters. Nitriles does not work or does not reduces the carboxylic acid or any other compounds. So simply there's a what I see over here, that's it's an ester group here, and there is a cyanide group over here, and both of them will be converted into CHO. So I think there is no need to waste the time. Simply just put the answer CHO and CHO. Like see 1 2 CHO 1 2 CHO, and then we have 1 2 CHO 1 2 CHO. It is good. A is the correct answer. So I didn't waste the time. I didn't take too much of time. A question, very easy one, asked back in JEE Main 2022, very much simply solved by us. Now let's move forward to another question. We have another process called as preparation of carbonyl compound using Grignard reagent. So this what we are doing it from the nitrile compounds, which are cyanide compound. So cyanide on first attack of Grignard gives you this C double bond and imine on hydrolysis produces you ketone or aldehyde respectively, depending upon what we are using with. Right after that we have, since we have already covered this part, I'm not just necessarily wasting the time. It's already been covered by us, that's why we'll move forward. We have Stephen's reduction. Stephen reduction is actually the what I say first reduction and then followed by hydrolysis with Stephen's reagents, that is SnCl2 and HCl. No doubt SnCl2 metal chloride with HCl is producing hydrogen. It's a reducing agent, and reducing agent reduces selectively. Then we have one product, imine on hydrolysis gives you RCH2 and ammonia. Okay, now we'll try to do the same basically question on the same concept we just studied. We have this carboxylic acid, a long chain carboxylic acid. Let me see what do we call it. Ohm's gap adipic palmic acid. This is palmic acid reaction with calcium hydroxide and on heating. So first of all, it will give you a salt, that CH2 simply on heating, what it will give you, one of the compound will be eliminated out like this, पाँच and छः. I think this is your final product. Let's solve. The compound D obtained through the following sequence of reactions. So there is a sequence of reactions C2H5Br on alcoholic KOH. The first alcoholic KOH will give you what? An alkene as a product. Then on Br2CCl4 what will give? CHBr, CH2Br. Then KCN will give you what? CHCN, CH2CN. And then this reaction, Stephen's reduction, and then hydrolysis will give you what? CHO, CH2, CH2, and then we'll CH. So this is what we are getting. Now these all reactions are pretty simple to us because we have come across all the reactions. We all know what reagents are used, what products are formed. Simply apply and get the answer. Here is another question. A mixed salt of calcium acetate formed, a mixed salt of calcium acetate formate on dry distillation. Okay, calcium acetate and formate means what is acetate? HC double bond O minus, and formate is CS3. Like this is formate and this is acetate. So again CaCO3 will be eliminated out, and CH3 C double bond H, CH3 C double bond CH3, and HC double bond H. All of these are formed, and minus CaCO3 in every step. Another reaction, what is this reaction called? We have acid halide H2PDBSO4. We also call this reagent as Lindlar catalyst. Lindlar catalyst on this reaction produces acid, this compound and HCl. The correct answer is, the name of the reaction is, I guess, Rosenman reaction. Then acetophenone can be produced by Friedel-Crafts acylation of benzene and what? So what we have to find aceto. So this is a benzene. In order to do the aceto, we got to react it with this compound, which is called as ethanol chloride. So C is correct. And then using anhydrous AlCl3, electrophilic aromatic substitution occurs and formation of this reagent occurs. And this is your final product called as acetophenone. This is called as acetophenone. So guys, do it today only. Enroll for your all India mock test series, and that is actually I remember, like, it's a free of cost series held by Unacademy, and just go and identify the platform, and it's starting for December 2022. Like 2022, no, yes, 22nd only, I guess. Tomorrow it is starting from. So give the test. For first test will be on Sunday, and stay confident and boost your confidence in your JEE journey, and just know where you exactly stand and where are you leading. Till now we have covered preparation of aldehyde and ketone, but now there are some methods. Using those we can specifically prepare only aromatic aldehyde. So we have another reaction here with us, preparation of aromatic aldehyde, and right after that we'll take a short break, and we'll have a breakfast break. Then later on we will be having a lunch break also, and this lecture will go till evening. So we are not running fast behind anything. We are just trying to grasp the concept, we are trying to applying it, and then we will get finished with this chapter. One of the reaction is called as that oxidation of methyl benzene, called as toluene. So toluene can be oxidized using chromyl chloride, CrO2Cl2, and this is called as chromyl chloride oxidation of toluene with a formation of a complex called as I call this complex is cockroach complex. So cockroach is why? Because sometimes it's pretty difficult to learn what is it written here. So we can form CH will be there, and it's a OCROHCl2. So we can see cockroach Cl. So cockroach it is forming, and then cockroach followed by hydrolysis. It will give you removal of this compound as HH, Cr, OSCl2 or water plus CrO3. It will be removed out, and it will gives you what? CrO3 plus water will be removed out, and that will give you CHOHOH, that is CHO. This reaction is called as Itard reaction. Okay, the one we are right now studying is called as Itard reaction, and toluene gives you the same product on reaction. Toluene gives you the same product on reaction with chromic oxide or acetic anhydride in separate if you are using MNO at high temperature. Then we have another reaction called as Gattermann-Koch reaction, one other very easy reaction, and we also call it like Gattermann formylation reaction. As you all can see, the reagent which we are using is exactly the same. We have done it earlier in the case of alkenes. So COHCl is given to us. This produces an electrophile called it C double bond or CH3. This is the electrophile we are generating. In electrophile aromatic substitution occurs, benzaldehyde is the product. Very simple, yeah. And the same reaction if you are carrying out in the case of phenol, then ortho and para substituted product will be formed, because negative charge density in the case of electron releasing group appears only at ortho para. So these groups are ortho para directing towards electrophilic aromatic substitution. Final product will be ortho and para product. We have one question: the reaction by which benzaldehyde cannot be prepared. Benzaldehyde. One is this reaction, and this is simply formylation reaction. A formyl group will come and will be attached over here, CHO. Benzaldehyde is formed. We have another reaction, ZnHG and concentrated Cl. This reaction, I don't know what will give you. It will not give you anything. Then we have third reaction, CrO to Cl2 in CS2. This reaction we just now have called cockroach formation will take place. Remember this, how I realized, and how is it formed? OCR, cockroach, OHCl2 whole twice. This is your, see, cockroach formation. Here we studied about cockroach formation. So this upon this is complex, by the way. This is your chromium complex, and on hydrolysis it gives you benzaldehyde and chromic oxide and water. Then an HCl also. So this reaction CrO to Cl2 followed by S3 has given you, and this will give you what? PDBSO4. This will be also giving you this Rosenmund reaction, CHO. So I think the only correct answer is B. So I don't know what B reaction is. Usually whenever there is a CHO, then zinc, mercury and concentrated HCl is this, I forgot the name. No problem. One of them was Volkishna Clemenson reduction. This is called Clemenson reduction, and the reduction occurs in such a way that the CHO group is eliminated out, and it just simply gets converted into CH2. Methylene group it gets converted back to. Next is JEE Main 2021, a question that was asked back in JEE Main 2021. So there's a huge compound we see, and this compound is allowed to react somewhere. So we have getting me, like we are now bringing two equivalents of this. So let's say one is getting attacked by, one is going here, and the another one going is here, and upon hydrolysis, so I think one should be CHO, the another CHO, not CHO, CH3CHO, CH3CHO, CH3 and the C double bond O will be there. So, and this will be converted into CHO. No, after hydrolysis we had one OH group, and there we had this. Then H2 for heat, there will be an alkene like this. So I think the correct answer should be B. No, yeah. How? Okay. More stable alkene you need to form. That is the only thing that we are doing. So, guys, pardon me, but the first reagent or the first compound that will be formed will be this. That this is the one compound we are getting. Now, a stable carbon will be formed after removal of this because we are using concentrated H2SO4. So, rearrangement of carbocation takes place. Carbocation comes here, then only alkene will be formed like this, which is actually resonance stabilized alkene, because alkene over here is in conjugation with this. There we got CH3 group, there is another CH3 group, and I think now we have prepared the correct answer. One more CH3 group is also here, and that is the same only C double bond O CH3. The correct answer should be now D. So I guess this was a good question, but the all required part from this chapter or this particular question was focusing on the reaction and its flow. So I mistakenly reached out to B, but the major part which belongs to the aldehyde ketone part, that reaction I did it completely correct. The only part that was dehydration of alcohol in presence of concentrated H2SO4, I attempted it incorrectly. So anyways, you always participate, stay confident, comfortable, solve it out, and then reach to your milestone. We have physical properties of aldehyde and ketone. So physical properties are like state. Physical state, generally they are gases, and this only formaldehyde is gas. Pardon me, everyone. Only aldehyde which present as gas. It's a very good information, by the way. It's a good information, and all other are liquids, and then up to C12 and then onwards will be solids. Then order, they are very smelly. Lower aldehyde give unpleasant smell, and the higher one are used in the, they have pleasant smell, and they give you, like, they are used in perfumes also. We have solubility, guys. So 1 2 4 are pretty much soluble in water due to the polarity, and there is a very less extent of H bonding which it can give you. But C5 onwards are insoluble because of the higher or the bigger hydrophobic part, the carbon containing chain, that is not soluble in water. Solubility is also inversely proportional to the molecular weight. Higher is the molecular weight, higher will be the hydrophobic part, less will be the solubility. And then we have boiling point. Boiling point is directly proportional to their extent of H bonding and as well as the molecular mass. Higher is the molecular mass, higher will be the molecular interaction, higher will be the van der Waals force of attraction, and higher is the boiling point. And also the boiling point works into this way. Why? Because alcohols are having, like, supposed to have the more interatomic or intermolecular bonds between them, which is because of hydrogen bonding, and which is absent in the case of what I call it, carbonyl compound do not show H bonding. They simply show a polar, or we can say like dipole interaction. There is no hydrogen bonding as such. It is just simply dipole attraction. Then we have density. Density of the carbonyl compounds is lower than that of water. Most soluble aldehyde, we know that aldehydes do not get easily solvated, or when they increase in molar mass it also gets reduced. So the smallest one, 2-methyl butane, 2-butanol butane, propane is the correct answer. Like, always pick the smallest. Finally, we are gonna to start our chemical properties, and for which we require some break as of now, and we'll keep on going till evening. But now I think it's the time that we should have some morning breakfast. So break time and do one thing. Just like this session. So we'll connect back soon. Allow me. So that was some healthy break we had, everyone. And now we'll continue from here. We'll complete our all the chemical reactions, because chemical reaction is the most favorite part of JEE, from which JEE prefers to ask questions from this chapter. We already have prepared these compounds. Now is the time that we should start their chemical reactions. So what kind of reaction do these compounds give? So since these are carbonyl compound, they usually give nucleophilic addition reaction in this way. So guys, let us suppose this is one of the carbonyl carbon. We all know that oxygen, being more electronegative in nature, has a partial negative charge. Carbon, being electropositive with respect to oxygen, has partial positive charge. Sorry. A nucleophile comes, attacks on the positive charge density. This electron density shifts like this. So a compound is formed somehow like this: O minus with one nucleophile here. This is how it look like. Then in last it may accept some H positive from either water or the medium available, and this is how somewhere hydroxy products along with nucleophile are formed. But this reaction you must take into account. This is your slow step and this is the RDS. So rate determining step for nucleophilic addition reaction is the RDS, and that's why these reactions are called as nucleophilic addition reaction. So what nucleophile can come and attack? Okay, take one more thing into account. Whenever this attack takes place, the carbon changes their oxidation state, hybridization state from sp2 to sp3. So if something is going from sp2 to sp3 and there is a possibility that carbon acquires a chiral center or carbon becomes chiral right after the addition of a nucleophile, both of the possibilities will occur, because an sp2 hybridized has a vacant p orbital on which the attacking nucleophile is going to attack. So that is what it makes it sp3 hybridized carbon atom, and if it is a chiral, it will give you D plus L form, which is like a acidic product it will give you. The rate of reaction is directly proportional. Okay, sometimes if the weak nucleophile is there or the acidic medium is given, then guys, first attack takes place of acid, which is a fast reaction, and the next step happens with nucleophile. This is a slow step, but again the RDS will be the nucleophilic addition only, the attack of nucleophile. But this kind of thing happens only if acidic medium is provided or the nucleophile is weak. In that case, the attack first of all happens on oxygen, and right after that the carbon becomes able to be attacked by the nucleophile. Then the reaction occurs in two steps. The again RDS will be the nucleophilic addition reaction. There are two effects which are so guys, if there is a carbon chain CH3 CH2 and some nucleophile wants to attack, nucleophile is seeking that this carbon atom must get more and more positive charge. But the problem is that inductively, by providing positive I effect, it decreases the rate of reaction. The plus I effect decreases the rate of reaction, and that is why with increasing in the chain, then if let's say if we are having HCHO will be having the fastest rate, then CH3CHO, then C2H5CHO, and so on. Exactly in the similar way, there is one more thing that we bring into the count, that is, let's say a benzene ring is given to you and a benzene ring is attached over here, and now this wants to acquire a positive charge, but because of the presence of this is called as positive M effect or positive resonance effect, again decreases the rate of reaction. So always remember that RCHO has higher rate of reaction, nucleophilic addition reaction, than benzaldehyde. This is what is this? Rate of nucleophilic addition reaction. I hope this part is pretty much clear to all of you. Then we already have taken under these all things in the account. So now we will reach out to some question, directly to a question asked in JEE Main 2020, JEE Main 2020. This question was asked. The question says that the increasing order of the reactivity of the following compound of nucleophilic addition. We all know that smallest will give you the highest rate of reaction. So benzaldehyde will stay at the end. Butanol, propanol, propanol, propanol. I guess this is correct answer, I begin. I think C can be the correct answer. D is also correct. Yes, D is also correct. So butanol, benzaldehyde. Okay. So aldehydes have higher rate of reaction than ketone. That is also we have to take under the account that usually. So aldehydes has higher rate of reaction than ketones. This is the rate of nucleophilic addition reaction. Even with benzaldehyde. So RCHO has always higher rate of reaction than RCOR, and also RCHO has higher than benzene CHO, and also benzene CHO has higher rate of reaction than RC double bond OR ketone. So take these things into account for the rate of nucleophilic addition reaction. So then you will get the correct answer that butanol, propanol, aldehyde. Propanol is the aldehyde, then benzaldehyde, then propanol, and then butanol. Now I don't think I need to explore or I need to give you further explanation. This was an easy question. We just went through the concept. We reached out to the correct answer. Next, number of electrophilic center. What is the meaning of electrophilic center? Electrophilic center. Electrophilic center is actually carbon atom, a positive charged center where a nucleophile can attack. No, I think probably I'm right or probably I'm wrong. Now let's see, nucleophile can attack where. So let us suppose check out this part, and let's say a nucleophile attacks here. This reaction density goes here. So that is how the reaction can went. Because of this conjugation only, this is working like O negative, and then methyl group is already there. That's one way. The another way could be directly addition. See? So this is again partial positive, partial negative, and that also can be explained in terms of partial positive, negative. So positive being acquired by nucleophile, negative comes here, negative moves down over here. This is how that's how it can work. Where can be the third attack possibly work? This is actually cyanide plus, and this is negative. So let's say if a nucleophile comes, attacks here, electron density shifts like this. That is how it works. So I think there are like three, and I don't see any other attack of nucleophile taking place. So 1, 3. The correct answer should be 3. Now I'll have to check the correct answer. What do you guys think? Are you guys aligned with me, or you find any different answer? Any other answer is not there. We have just answer 3. Next question, the conversion of propane 1-ol to N-butynamine involves a sequential addition of the reagent. Conversion of propane 1-ol. How come only reactions are coming and we haven't even studied any single one of them? So we have propane 1-ol. Okay, we'll make it like this. And we are getting it to N-butylamine. N-butylamine. Butylamine means one more carbon atom is coming. So we have to anyhow it convert into cyanide. So let us see what reaction can we do. First, try SOCl2, get it converted into Cl. Try KCN, get it converted into cyanide. Try H2NiPTPD. And what is this mercury? Okay, this might be simply producing the H2 holding the reagent, and then it becomes what? I think that's it. That is the final product you are getting. Well, let us suppose meanwhile this has also formed. And then finally so barki ho gaya. So A is correct, I think. First HCl will not do, yeah, will convert it to, okay, no, it will convert this Cl, because rearrangement occurs. It will not be attached over here, it will go somewhere in between, because rearrangement may occur. Carbocation rearrangement takes place, and rearrangement doesn't lead to the formation. What is the desired? What is desired one? SOCl KCN, then KCN with an CH3 NH2 do what? This does nothing, and then HCl cannot undergo. Only A is correct. Check it out. A is perfect answer. So this is what happens when you are pretty much confident about your concept, and every time you will be doing the correct answer only. Because guys, my way of like operating and my way of solving the questions is a bit different, and it is absolutely equivalent to the students. How do they try their questions? Rather than being a teacher, I always opt to be a student. Whenever I teach something, I have already created a theory in my mind, and using that only I solve the problems, and I always reach to the correct answer. And that's what I want every one of you to be, because believe me guys, chemistry is huge. Chemistry is very vast. When you'll be going in BSc or MSc doing your projects or doing your graduation, post-graduation, you'll find that only a single topic will be there that you have to carry out for your coming 2, 3, 4, 5 years. And believe me, in this 1 or 2 year, we are right now studying whole chemistry, which is like very vast. So rather than going very deep dive into chemistry and unnecessarily getting attached with any kind of topic or mechanism or any kind of concept, it's better that we must know how to abstract the marks out of it. Always use all the techniques of like learn it or remember it, or you can formulate it, or you can use any shortcuts to remember it, or sometimes where you can use the application part like learning the mechanism or learning the derivations, then also you can operate. So be very flexible in chemistry. That is the only advice to all the aspirants of JEE, and believe me, you will get maximum of the marks in chemistry. Now moving forward, and it's a good thought I said, so I must take this thing and we'll create a shorts of it. 217. So note down that the reaction takes place in the presence of mild base, which abstracts the, okay, what we are reacting with, nucleophilic addition of HCN. So initially what you are doing is cyanide ion will come and attack, or somewhere we are already having H plus. So reaction is to take place in mild base, so that mild base can react with HCN producing cyanide ion as a nucleophile, and then followed by the further H plus will be attacking there. The HCN and this cyanohydrin, the product in which carbon 1 atom, like one of the group is hydroxy group and another one is cyanide group. This is considered as the very important compound in chemistry for the synthesis of so many good things, just as its reduction causes you this N beta amino alcohol. N beta amide you can produce using partial hydrolysis, then using full hydrolysis you will get COH, and then on reduction and followed by the sequence Stephan reduction you can get CHO. I don't think this something requires further explanation because this is something that we already have covered till now. So just stay focused, try revise it by your own, and then you will get your final answer. Now reaction with water, which is a reversible reaction. Why is it a reversible reaction? Because water is not a good nucleophile, it's a weaker nucleophile, and that is why it requires that and even the product, guys, the neutral hydrate is like as you all know, like unstable. So stability of hydrate depends upon the steric hindrance. Lesser is the steric hindrance, higher will be its stability. Presence of one first group on gem diol carbon. So present of first group on gem diol carbon. So this carbon, if it contains presence of a group 1. Sorry yaar, minus I yaar. So minus I group is there. So minus I group increases the rate of reaction, making it more positive charge created. Let's suppose this is a minus I group attached here. So this will create more positive charge over here. So that's why there is a more possibility of water to attack here. Then intramolecular H bonding sometimes happens, makes it more stable, and there is an angular strain in the carbonyl compound. We have a reaction, we have a question here. Cyanide is being attacked here. Cyanide will attack where? Carbonyl carbon, and it will give you CH3CH2 CN. Cyanohydrin is the product, guys, and this on concentrated H2SO4 and heat will give you what? I think alcohol. So this is your alpha carbon, this is alpha and this is beta. This is alpha, this is beta, and then occurs the even elimination. I think B is the correct answer. Next is, how many of the possible can make stable hydrate? So what do you think, where can we get the stable hydrate? Let me recheck this. What is it? Okay, I'll give you the way. So how is it made? So here what I can see is जिद्दी जिद्दी है तूफान. This is where we will be getting a stable. See, this is again stable with the H bonding, as well as some electron withdrawing group is attached here, which also stabilizes it, because electron withdrawing group will increase the positive charge density to be attacked by water molecules. It will form readily. Now what should I do with this? So these are the pretty similar only. जिद्दी जिद्दी है तूफान. सलाम रोकी भाई. Okay, this will not form anything. Because where should you attack on? Like, where is the possibility to be attacked upon? If steric hindrance is there, it is just simply steric. It will not give you any product. And that is what I'm not even sure about the third. हार्दिक, हाँ भाई. So guys, that is the possibility we have, and what others won't do, this will not do any stable one because of the steric reasons. This will not go. I think 1 and 2 is the correct answer. So that's it. And somewhere in the chloral also, one of the electron withdrawing group, wherever the electron withdrawing group is there, that will also form a stable hydrate. The equilibrium constant values for HCN addition to the following aldehyde is in the order of, बताइए. That's it. So which will give fastest? So I think this is what. So this is actually positive M more than minus I, and this also has a positive M more than minus I. And out of these two, I guess nitrogen has higher. Second is the fastest will have. Second will be the fastest for this reaction because no group is attached there to compensate the positive charge here, and the higher is of the third one. The positive M effect is of the third one is higher. So we'll see third one become the worst, second is the best. So D is the correct answer, because it's simply based upon the that minus M, sorry, positive M character, positive M effect is actually OMe has lesser than NMe2, like that. Another question, which is most reactive toward the nucleophilic addition? You tell me. Most reactive. So most reactive should have minus M more than minus I, and I think D is the correct answer here. Then we have an assertion reason question. Assertion says that cyclopropanone undergoes addition with HCN and more easily in comparison to the acetone. So acetone is what? Cyclopropanone has this structure, and this angle is actually very lesser. So this is what? How much? 60 degree. So this has easily to be attacked by the nucleophile. Basically lesser hindrance because of the compact groups we have, these one. Then we have cyclopropanone contains strained ring and also has less steric crowding. That is what the reason is also correct about it, that less steric crowding will lead this formation. Both are correct and reason is absolutely correct explanation. Chloral hydrate, we were actually talking about this compound. Then so what is a chloral? CCl3 and C double bond OH. This compound is being attacked by water, and then it forms Cl, 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 C, OH, and it shows a H bonding like this. So this is a stable complex it forms. So what is it asking? It is due to the high molecular weight. So chloral hydrate is stable because of high molecular weight is incorrect. This is false statement. This is a true statement. So assertion is correct, reason is not correct. C is the correct answer. So what is the product that will be formed? Okay, first of all, what will happen? This deuterium containing this O18 will attack here. So CH3, C, this O16 with a minus charge. We have ODD here. And this O is actually 18. Then intramolecularly, this hydrogen departs and attacks over there. Then this is how it is formed. CH3. See, this has OD with 16. This is OD with 18, and this is a simple hydrogen. Now check it out. 16, 18 both together, OD, OD, and one hydrogen. B is correct. हाँ भैया, हाँ, यस सर, मैं स्टूडियो 5 में पढ़ा रहा हूँ, रख लीजिए ना। G. So there we go, guys. This is where we have finished this topic. Next is, which of the following is more stable hydrate with H2O? So where you can get the more stable, wherever it is the least possibility of hindrance, least hindrance is there, that will give you the most stable. That is correct. Next is nucleophilization of ROH, third reaction, and with ROH you will be getting acetal and ketal as the product. So this is a ketone. Ketone gives you ketal, the very pretty name, ketal. And this is called as hemiacetal if OR and OH groups are there. So although these two are also unstable, but they are relatively stable than the 2-hydroxy group or the hydrate. Hydrates are exceptionally stable under the conditions of external things, like hydrogen bonding is occurring, or very less steric hindrance is there, or some external factor has arrived there of electronegativity, like that. Then aldehyde also form acetal, homoacetal, and then acetal is the final product. Then we have nucleophilic addition reaction of ROH alcohol. So alcohol, how does it operate? Let's suppose there are like two alcoholic groups are there. This is like we call it like glycol, ethylene glycol, and glycol on reaction with this, it produces a compound like this, which is a acetal. The acetals and ketals are hydrolyzed with aqueous mineral acid to give you regenerate the aldehyde and ketone. So this again with the acidic condition can give you back these reactions. Fourth one is the attack of sodium bisulfite, or it is in the form of Na plus and HSO3 minus. So actually the attacking reagent over here, it seems like is oxygen, but believe me, oxygen doesn't attack. Sulfur attacks here. Because of so formed, its structures will be more stable in the case of where sulfur is attacked there. It gives you 3 resonating structure rather than oxygen connected over there will give you just 2 resonating structure, and that is the only reason there which sulfur attacks over here. So always remember this reaction that oxygen is not attacking over here in the carbonyl carbon or the carbon which is with positive charge. Actually it is sulfur attacking there, and this is how the proton transfer takes place, and white crystals of this are formed. So that's why it's a good basically reagent to distinguish between the aldehyde and ketones, because ketone do not give any reaction with sodium bisulfite. Ketone do not give this reaction, only aldehydes give this reaction, and here it is given that bisulfite redox is important compound because it gives you carbonyl compound further by hydrolysis. If we go for hydrolysis of this compound, this will also give you the same aldehyde ketone, and the reaction is not given, it is only given by methyl ketone. Methyl ketone is actually your acetone. Higher ketone do not give this reaction, and it is also not given by acetophenone, but all aldehyde give this reaction. So what is the mechanism? I told you that sulfur attacks there, sulfur attacks and can form this compound, and after hydrolysis it becomes SO3H. Also remember that HOC3 is present in higher concentration, and sulfite, this ion is better nucleophile. The reaction HSO3 minus with AOH minus produces water plus SO32 minus, which works as a nucleophile. SO32 minus is the nucleophile. Again sulfur is attacking. Which of the following compound does not react with NHSO3? Acetone, it gives, acetophenone doesn't, and only acetone is the ketone, only ketone that reacts with NaHSO3. Next is there is a compound, we are getting it attacked with methyl hydroxide, which is actually methanol, and the product should be what? So this is how it will look like. OH and then OCH3. This is the product A. Because this is simple, yaar. Just simply go there, attack it like this, or maybe in acidic medium, first it will get O minus and this. The reagent which is used for the separation of aldehyde, acid aldehyde. So acid aldehyde is CH3CHO. From acid of phenone. Now what is acid of phenone? CH3. So this is correct answer should be A, because this will react, this will not react. JEE Main 2020. One of the question was asked in JEE Main 2020. Let's see who can solve this question. We have a question, everyone. The question says that the correct match between the item 1 and item 2 of this reaction preparation of benzaldehyde is. Oh my God. Forgot to bring. Shut out of it. Okay, try this question. Correct match we have to find out, everyone. Correct match. So item 1 is benzene, and second is what? I don't know. Second is reagent. The correct match between the starting material and item second to prepare benzaldehyde. Okay. The final product should be benzaldehyde. The outcome which we are getting right now is benzaldehyde, CHO. This is the final product. Now you match the correct reagents. Benzene on reaction with CO, HCl, right? So this is first. Benzonitrile should react with HTPD, no. Benzyl chloride can react with this, and this will go with HCl and SnCl2, where it will be reduced down to NH imine, and then on hydrolysis produces CHO. So pick the correct answer. One is R, first is R, second is P, and third one is Q. A is the correct option. Isn't it very easy question? Yes, very much easy. Next question, addition of ammonia and its derivatives. You know the meaning of ammonia and derivatives? You all know about ammonia? So guys, this is ammonia, NH2. So we write it like this, NH2, and there is a hydrogen. If this hydrogen is substituted, is replaced and added by a G group, then this becomes derivative of ammonia, and this is simply ammonia. So how does it react, by the way? It's another very simple part. We have this group C double bond O. We have NH2 part here, and there is a group G. Always react it like this. Remove the water part and simply make a compound like this. This is how we work. Shortcut. This is the shortcut of getting the final product. But I will also give you the correct mechanism. How does it work? But first you learn about it. So how this reaction works actually? So let us suppose there is a compound, carbonyl compound looking like this. We are first reacting with ammonia, let's suppose. This will come like this, this will go like this. This has become NH3 plus, by the way. O negative, two groups are there. It will basically intramolecular proton transfer will take place. This becomes OH and this has become NH2. Again, exactly like OH groups were unstable on one carbon atom, this combination is also very much unstable. This eliminates out water out of it and forms the compound like this. This is your compound final outcome. Now this could be your G group if it is in the case of we are using what? G. So directly you got to form it like this, or simply you can form what? Simply C double bond O is there. Put it like this, show it like this, ammonia derivative, remove the water, and also you will be getting the same product. See, check it out, double bond N and then H is here. Now this H could be replaced by G. I think this part is absolutely clear to all of you, isn't it? Now I don't need any further explanation. I don't need to explain every single part right now. Why is it so? Because you already have covered the part. You already know what could be the possible group G, where we are representing it as H, and there could be the final product will be C double bond N and Z. Now this Z could be any part, such as Z is right now ammonia hydrogen, amines are hydroxylamine OH, hydrazine is this, phenyl hydrazine is this, zup, 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 zup. Then we have carbazide and this. So I'll give you two important example here. One is the hydrazine. So guys, let us suppose this is one of our this. We have NH2 here. We have NH. Then we have 2 and 4. This compound is called as 2,4 phenyl hydrazine. 2,4 phenyl hydrazine. Then the reaction you all know. How does it work? The shortcut we know. H2 will be removed as water. H2O is eliminated out, and the product form will be, this is 2,4-DNP test. C double bond N. Then we have NH with a benzene, and 2 and 4 will be the NO2. This is called as 2,4 phenyl 2,4 dinitro. And this is 2,4 phenyl hydrazone. This is phenyl hydrazone, and which are actually orange colored crystals. The phenyl hydrazones are what? These are orange colored crystals. This is your 2,4-DNP test. So this is also called as Borch's test, in which we are getting treated, and this is your orange red precipitate. This confirms the presence of carbonyl group. This is called as 2,4-DNP test. The another one was your attack with, let me check what was that compound, semicarbazide. Amide group will be there. So this also looks like this, NH2, NH, C double bond O, NH2. What is this compound called? This is called as semi carbazide, and we are getting it treated with aldehyde ketone, which is our carbonyl compound. So again this H2O group will be eliminated out. So this is how we make the final product. We call it semi carbazone. These are some set of reactions, guys, we use. Some of these compounds which are formed as a result are highly important compound, and they show the presence of and even the creation of newer compounds. So hydroxylamine is one of them. So this is what we have done till now. Addition of ammonia and derivatives has occurred. Now some other than that reactions we have. Ammonia and derivatives have been already taken into the account. Now some other reactions are there apart from that. And what is it? First we are treating our HCHO with ammonia. The reaction similarly occurs initially with the same thing, that nucleophilic addition will occur, but reaction may lead to the formation of further compound, and there is a compound called as, I don't know what's the name of the urotropin. We call this compound as urotropin, which is actually hexamethylene tetraamine. This is how it look like, and this is used as a diabetic or urinary infection medicine. Learn it and note it down, and then we'll move forward. Hmm. 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 So now next is the addition of ammonia with acetaldehyde, and it forms acetaldehyde and ammonia product, which later on after removal of water forms acetaldehyde, and we already have formed this product, not a problem. This acetaldehyde goes polymerization to a non-aromatic heterocyclic addition trimer named as 2,4,6 trimethyl hexahydro 1,3,5 triazine trihydrate is the main product. Oh my god, what is this? Yeah. Oh, yeah. Oh, yeah. Anyways, we'll move forward. We are not concerned about what will be the final product. Leave it behind. Just move to the next one. Now we have acetone is now heated in the presence of ammonia and it forms diacetoramine. And how you can check it out. So acetone with ammonia will give you an amine kind of product which later on reacts. If acetone and ammonia would be in excess, then the product will be triacetoamine. If triacetoamine is heated at high temperature, it converts back into heterocyclic compound by the elimination of water. So remember the reaction, guys. Just take an idea and move forward. Not a very huge reaction to learn about. We already have covered so many important reactions till now, and this is somewhere we can just get the idea what is it formed as a polymerization product, or what is it formed with the triacetone amine. Then ammonia reacts with benzaldehyde to form hydrobenzamide. Hydrobenzamide somehow look like this, hydrobenzamide. So this is something the attack would take place on, and so like this is how we can form. Two reagents can be used of benzaldehyde, and then we have ammonia. Two ammonia use are this, and this is the product we form. Next is, what is the product of the following reactions? We already have covered this part. We'll come to know the reactions. We can form a double bond N OH, which is the hydroxylamine. There we have one reaction. So guys, this is very easy. You can make it by your own also. Ziddi ziddi hai tufan. PHCH2 CH2 CHO. This NH2 will be used, remember, and then it forms, what is it, carbazone. This is semi-carbazide. Then another reaction, this is what will be used, pH double bond N pH. Try all the products, everyone. Make them by your own, practice them by your own. We have one question, how many of them will give you 2,4-dinitrophenyl hydrazine test? So who gives it and who doesn't, I'll tell you. 2,4-DNP test is not given by other than aldehyde and ketone. So all the aldehyde and ketone gives this test, not other than that will give you this test. How many of these will give you? Okay, this will give CHO, Glucose also have aldose, aldehyde group. Fructose also has aldehyde group. No. And no. Only aldehyde ketone. Done. In 2021, this question was asked that 2,4-DNP can be used to identify aldehydes from amines, ether, and halogen. We have question back asked in 2019 that this product will be what? I don't know, man. So NiH2 is there, diisobutyl H is there. See, this will form. First, it will be formed. Let's say this is converted into CH2 NH2. Now this NH2 is actually working as a nucleophile. Internally, it will go and attack here. Now first you have NiH2. So NiH2 can reduce cyanides, I can think. Okay. Oh. Oh man. So guys, what I think is this reaction is some difficult reaction, not so easy to determine, but we have plenty of things to discuss here, and we'll see that what comes the final product. So this is how the final product will look like. This is benzene and this is also benzene, and nitrogen is taken. They see 1 2 3 1 2 3. This is nitrogen now. ज़िद्दी है तूफान. NH. This can reduce amides also. Correct answer is actually D. How can I get D? Check this, everyone. D is the correct answer, showing it to me. Too fun, too fun. No, 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 no. Let me check its answer, everyone. I have no idea where I took this question from. So anyways, let's come back. So how is it working? First of aerial, जिद्दी जिद्दी है तूफान. First we have OET and then cyanide. So under the influence of H2Ni, we have a strong reducing agent, reduces everything up, and it doesn't reduce to alcohol, so we'll make everything reaching to alcohol at first. OET will remain like this, and we have 1 2, we have 1 2, and then we have NH2 like this. This is what the first product is. So what should I do? What is diol H doing here there? Guys, this ET takes this hydrogen and remove out in the form of E2OH and forming a compound like this. OH, we have NH, one of the H is removed. Like this. Further, this OH and this H goes out. Same compound, same carbon atom having one NH and OH. Water is eliminated out. The correct product will be benzene with another NH group, and this is where double bond is formed. Now pick the correct answer. D is the correct answer. Now that is how it is working. Actually, there are like so many reactions involved, and we have vitamin protein with us, and thank you vitamin protein you for this correct submission. D is the correct answer in this set of reaction. It's not just one concept involved here. There are like plenty of the concepts involved here, and that's why it took us some time also. So now we'll be reaching to the another reaction from here, everyone. We have the another reaction where we are getting carbonyl compound reacted with PCl5 or SF4 that we have done for alcohols also. You always presume this thing, like since we have done this part earlier, that one ROH on a reaction with PCl5 gives you RCl, POCl3 plus HCl. Now do the same reaction using this RC double bond OH. Consider it as RC OH OH, and we will use PCl5. Its two equivalent will be used and will give you what? RC, we will be giving Cl and Cl, and then we have one H plus 2 POCl3 plus 2 HCl. So that's how we'll treat this reaction. So geminal dihalide will form. We have another reaction with SF4, exactly the similar reaction, and there also we have difluoride attached over here. SN2 reaction takes place. Then we have addition of RMGX to. So guys, this is where we form this R minus is a very good resource of nucleophile, attacks on carbonyl carbon. O minus goes like this. OH will be formed somewhere, and this is like primary alcohol is formed only by methanol, or we can say formaldehyde. So formaldehyde or methanol is the only reagent that upon under attack with RMGX gives you primary alcohol. Then we have this one, higher aldehyde. All the higher aldehyde, then methanol will give you secondary alcohol. One is the R already attached, another R will come from here. RMGX will attack, and this is called secondary alcohol. And then we have ketone. Ketone will always produce tertiary alcohols. We have 3-degree alcohol. Check it out. I hope this is good to all of you. People are getting it. Now I'll take you to another question on the same process. Remember that alkali organometallic compound react the lead in the same manner, because all the alkali metal will have Li minus, Li plus and R minus ready-madely produce R minus. The order of nucleophilicity is organometallic compound, we all know, and basically rate of reaction directly proportional to the basically covalent ionic nature of the bond, ionic nature of metal carbon bond. So we have R minus here, ready-made, then R2Z and R2CD, R2CuLi. This is how the reaction goes. Next, now we'll try some question from here. Do we have any double bond here? Maybe seems like. I think there's a double bond. So now this CH3 minus has two option. One attacking over here, this goes there and this goes there. And extended conjugation gives you the stable product like this. Now what is this? This is an enol. This enol will tautomerize back into keto content. So this is what we are doing here, yaar. So that is how the final product will come. A. Sequence of reaction. A is the correct product. So second type of reaction, apart from nucleophilic addition, we have reduction of the carbonyl compound. So we'll reduce, but always take these things into account that we have some strong reducing agents, some weak or selective reducing agents as well. These are some set of strong reducing agent which will reduce up to the alcohol, and then we have some reducing agent which will reduce up to hydrocarbon. Okay, these are two different categories. We have Clemmensen reaction, we have Wolff-Kishner reduction, and then we have red phosphorus and HI that will cleavage the C double bond up to CH2 group, and there it will go to the alcoholic part. So number one is called as Clemmensen reaction. Simply learn it that this reaction occurs in the presence of concentrated HCl, and zinc amalgam is used as a reagent or as a catalyst here, and it reduces that CO double bond. C double bond O is simply converted into CH2. Always remember. But this reaction is not suitable for those compounds which contain acid sensitive group like OH, NH2, alkene, etc. because under these group the reaction may react with that group present over there and may not give you this product which is the required one. The next one is called as Wolff-Kishner, which occurs in basic medium. NH2 and NH2 is called as hydrazine. This hydrazine is used as a reagent, along with we have strong base in the, so this is basic medium we are using. Ethylene glycol is also we are using. So this reaction again does the same, but it is not used where the base sensitive group is present, such as halogen. Halogen will be first substituted by basic group such as OH minus. Next, third is called as reaction with red phosphorus and HI. Whatever the compound given, whatever, this is considered to be the most strong. Most strong is what is strongest reducing agent, and it produces what? Alkane. Simple. RCOH, RCOL, anything is there, directly converted into CH3, CH6, CH3, CH. Just learn it out. No need to take under the account of the mechanism. We don't need to learn the mechanism. Only simply learn the reaction, how the reaction works. What is the reagent? What is the product? That's it. Then we have reduction to alcohols. Now alcohols, we have so many important reagents to be used. So just learn them. At H2NI PTPD, catalytic reduction occurs, converts into alcohol. NaBH4, LiLH4 are also two which we are going to use. Lithium, aluminum hydride, and sodium boron hydride, in which LiLH4 is relatively stronger reducing agent than NaBH4. NaBH4 only does reduce to aldehyde and ketone, not to the esters, carboxylic acids, and all. And NaBH4 can also reduce the RCOCl, which is your RCOCl acid halide, but rest LiLH can reduce to all ester, amide, and even acid, all. So take this idea here. Just note this thing down, and I'll be back shortly. Yes, everyone. So, have you all written this down? So, we have reducing agents such as H2PT. These all reagents reduce your respective aldehyde and ketone to their alcohols. So, now we have reduction to alcohols. So, we all must remember that LiAlH4 does not reduce alkenes, neither NaBH4 nor LiLH4. Only H2NiPTPD they do. But a cinematic aldehyde, cinemaldehyde, like cinematic system is given. Cinemal system means there is a carbon double bond carbon, next is CHO group, which is like a resonating or conjugate system is there, in which both of them will be reduced to alcohol, as well as the alkene is also reduced to alkane. But if this is the case, then this alkene will not be reduced, only this part is reduced, and the same happens over here. Even if an alkene is directly there, it will not be reduced, only the alcohol part or this carboxy part will be reduced. Next is called as Bowelt-Blanc reaction, in which sodium and ethanol will be used. It is the same reaction. Sodium and ethanol will react each other, will produce hydrogen. That hydrogen reduces this compound and forming the ETO, which is the final product. The reaction could be a free radical mechanism, can be shown by sodium producing one electron. This electron goes there, makes O minus and C radical. C radical attacks on ETOH for accepting its hydrogen, then gets hydrogen and becomes OH anywhere with like this. The reduction by this is reduction of benzaldehyde will give you what? Benzaldehyde undergoes reduction via coupling reaction and form the vicinal diol. Okay. This is the fun part, vicinal diol. And why does it happen? Because this radical is highly stable, and this stable radical makes more stable radical and gets connected together, which is not possible in the case of alkyl one. So alkyl simply goes with the formation of one alcohol. They may polymerize or dimerize. Then we have ketones also undergo reduction via coupling reaction, and product will be vicinal diol with presence of magnesium amalgamated and have water. This is called as pinacol. Okay, vicinal diols are called as pinacol. So when the reaction is carried out in the presence of MgHgTCASL4, this product is a vicinal transdiol. Okay, cis diol, and now we are having transdiol in the presence of TiCl4. Just take the idea, no need to further deep dive into it. Just take the idea and move forward, that's it. Just short note it and just move forward. Won't be asked in JEE Main point of view, that is what I'm sure about, not even given in NCERT. So we have 1-hydroxy 2-butanone reacted with red phosphorus. What will be the compound? It will be the final one single line butane, because it is red phosphorus RHI, the strongest reducing agent. Next question is, this is a question, the conversion will be achieved by, can you see this reaction? Can you examine this reaction, everyone? Can you examine this reaction? This reaction is what? This is a base sensitive reaction. A base can attack here. A base connect here and can reduce and can remove this part. So we are not supposed to take the Wolff-Kishner reaction, and Clemmensen reaction is the best one because the reaction should be carried out in acidic conditions. And since AlIH4 and ABH4 cannot reduce C double bond of CH3 in CH2CH3, so we have to use Wolff-Kishner or Clemmensen only, but the base sensitive group is there, so that's why we use B. There we have, in conditions of acidic, what we have, if an acid comes, this will first attack here and it may eliminate out as an alkene, or any reaction may occur, but you have to want to this thing over there, we cannot use it. This can be used, C, because acid sensitive group is there. In the previous one, base sensitive group was there and we used Clemmensen reduction. Next reaction. So first of variol, this will be converted using this Clemmensen reduction. This is your Clemmensen reduction. This will be converted into my life is like this. Okay, this will be removed. No. And this part, what about this NO2? NO2 can be reduced by H positive. I think this is the correct answer. NH3 plus is the final product. Because of this acid. Which of the following is not correctly matched? Clemmensen, correct. Wolff-Kishner, no. Wolff-Kishner also leads to the formation of CH2. Rosenmund, correct. Stephens, correct. In the following reaction, JEE Main 2019 question was asked. JEE Main 2019, everyone. Let's try the correct answer. Aldehyde plus alcohol gives you acetal. Best combination. The aldehyde should be the smallest one. And alcohol which is attacking should not have too much steric hindrance. It should be the smallest one. So now tell me the correct answer. Best combination. A. The major product of the reaction. AlIH4 does not reduce alkene. COH it can reduce. Tell me the correct answer. Isn't it D? Yes, it is D. One more good question here. One more good question. Reactions are plenty. So we have one question. First is conversion of ester to alcohol. Ester to alcohol can be converted using any of the reducing agent. Let us suppose if you are using diol H, can reduce it to ester to aldehyde. Fourth is SnCl2 to H2O. SnCl2 to H2O. I think this is good. C is correct. This will be done using this. This has P. Chalte, chalte. Ester to acetate is diol H. फासले हो गए. This is esterification. Opposite to esterification, saponification taking place in the presence of esters of ore and water. And at last, nitrile should first everything is done now. So we have A is matching with Q, A is matching with second, B is matching with third, C is matching with 3, and D is matching with first. I think A is correct answer. What do you think? Is A correct? A is absolutely correct. Thankfully, this chapter is actually huge. Yeah, there are like plenty of chemical reactions involved in it. Plenty means lot of. There are a lot of chemical reactions involved. So we have this reaction called as Tollens test. So guys, I have already explained this part. There are some of the oxidizing agents which are strong, which generally oxidize the given aldehyde into carboxylic acid directly, and to ketones also they oxidize them under the drastic conditions to provide them the carboxylic acid part. Then we have mild oxidizing agents also, which will like oxidize them under mild conditions and Ketones will not give these tests because ketones are not getting oxidized by the mild oxidizing agent. That is what the difference it creates. We'll first come up to the tolerance test, very important test. This is very important test, everyone. What tolerance tests do? In tolerance test, we have, it is also called as ammonical silver nitrate test. So I'll explain it to you over here because it's a very easy test. So guys, what do we do? Ammonical silver nitrate can be written down into this is AgNO3 silver nitrate and this is NH4Cl, or this can be written down into AgNH3 whole twice Cl. This can also be written down like this, Cl or whatever it is, yeah, NH3. So how this reaction goes? What do you think? This is our tolerance test, tolerance reagent, and this can be reagent. This reagent can be represented in either of the way. So this reaction is occurring with a aliphatic or aromatic, whatever the aldehyde is there. So you all know that the oxidation state of silver over here is +1. Here it is positive 1, and then under the reaction it is oxidized to क्या पता कहाँ हम चले. This is how it forms a compound, or hydroxy compound. So we can say that this has been oxidized, and this will be silver deposited down like this, form the silver mirror. This is why we call it silver mirror test. This is solid silver which is deposited on the side walls, and you can find out the oxidation state over here has become +3 and this has become 0. So this is oxidation reduction reaction. You are not supposed to balance the reaction. Even if you want to balance it, you may do it, because you all are pretty aware of the redox reaction. You know how to balance redox reaction. You can find out the N factor respectively, cross multiply them, find the whatever you want. So this is why we do not need to balance the reaction, and this is one of the very important reaction, by the way. This is called as tolerant test, and both aliphatic and aromatic compound gives this test. Aliphatic and aromatic aldehyde give this test. But ketones do not give this test. Ketones don't give this test, everyone. And always remember, hemiacetal alpha hydroxy ketone formic acid also show this test. हाँ भैया कहाँ? So now let's see the other reaction first. Fast we'll go. So how hemiacetal alpha hydroxy ketone, formic acid, they also give this test, and also terminal alkynes. So remember this part. They also give this test. But this reaction might not be silver mirror test. Take example. Let us suppose some alkyne is given. This alkyne has an acidic hydrogen, and in the presence of this silver mirror test, AgNH3 whole twice Cl, the reaction gives you a test called as CH triple bond C minus Ag plus, which is a white PPT. So this is called as tolerance test, but this will not be considered as a silver mirror test. It is just a tolerance test. So now this also gives this test. This is called as formic acid. This is terminal alkyne. under the same reagent. And produces CO2 as the product, plus silver will be deposited down. Next could be, what were the other examples? Alpha hydroxy ketone. So alpha hydroxy ketone is this is some alpha hydroxy ketone. This has an acidic hydrogen. We have a so guys, again this is also not a silver mirror test I find, because only under the basic conditions this reaction leads like this. This is the hydrogen which is departed and this forms CH2 O negative, then it is C double bond O. And this is actually stabilized by so first of all let us say this forms an enol form, and in its enol form what is this written here? Shit, unnecessarily kidding me. Okay, there occurs one more thing over here, and the one more thing that occurs is this hydrogen may go like this, and अरे यार क्या है, चेक करना पड़ेगा यार. It is saying that it can be converted into tautomerase into aldehyde. Okay, so this is how this reaction may work. Like in the case if it is undergoing tautomerization, I find this reaction can go in this way. See, uh, so this is alpha, and this, let's say, tautomerize. So this will become CH2 OH double bond C HCH3, and another OH here, enol. Then this hydrogen can convert it back over here and can produce another C double bond OH. We have CHOH and CH3. Now this is like aldehyde. An aldehyde we know can give this test. So this is how it works. So there are few of the compounds that also undergo this reaction, and we have to just learn them. Like apart from aldehyde, there could be some more substrates which can do this reaction. Like one of them is alpha hydroxy ketone. What else is there? Hemiacetal also form this reaction. Hemiacetals also give this reaction. OH and OR group is there. So terminal alkynes also show positive tolerant test but no silver mirror. Next is coming to the next one is called as Fehling solution test. So our Fehling test is actually made, Fehling solution is actually two things. This is called as Fehling solution A. This is called as Fehling solution B, sodium potassium tartrate, or we call it as Rochelle salt. Rochelle salt. So guys, this is also very easy reaction, but believe me, this is only done by aliphatic aldehyde, not ketones, not aromatic. They do not give this test. Fehling solution is very easy. We are getting reaction with Cu2 positive, which is actually blue in color, and then the reaction occur in such a way that this forms R O minus. And this gives you Cu2O. Oxidation and reduction, this is +1, this is +2, this is +3, and this is +1. So this is getting reduced. This is actually brown red PPT, and this one is blue color changing to brown red PPT. That means it gives you the positive Fehling solution test. Balancing can be done by your own. That you can do by just finding and factor, cross multiplication, everything can be done. We have similar kind of basically test called as Benedict test, exactly the same. The only difference over here is sodium citrate plus sodium carbonate. This is your Benedict solution B. The only difference is this. The rest everything is going for the same. So the dark blue color of copper is now converted into blue color copper in converted into copper sulfide red PPT. Next is called as mercury chloride test. Mercury chloride is GCl2, which is present in +2 and gets back into +1 oxidation state, called as Coulomel. This is +1, this is +3, this is +2, and this is +1. This is a simple redox reaction happening. Always remember, this reaction may lead you to the formation even with this. So it is reduced by aldehyde to give a white PPT of mercurous chloride. This is white PPT, which also further reacts with the aldehyde, giving you black PPT of mercury. Then we have Schiff's reagent here. Schiff's, what is Schiff's reagent? Schiff's reagent is actually a huge compound looking like this, and it is actually colorless in color, but when it reacts with an aldehyde, it gets converted into magenta color or like purplish color, pinkish. So aldehyde react with this reagent to restore the pink color. हेलो, हाँ, now we'll move forward. Stick the idea, no need to learn down everything. The Schiff's reagent, this has two aniline groups attached with a carbon doubly bonded with this group and connected to this. So actually it is like also called as like para-rosilin hydrochloride, or it's a magenta dye, which is your Schiff's reagent, and then it reacts first with SO2 to discharge its color by passing SO2 gas, and then the colorless solution is then called as Schiff's reagent. So this, when it is passed through this dilute solution of hydrochloric magenta dye passed through SO2, discharges its color, become colorless. Colorless reagent reacts with aldehyde, restores back its pink color. Only aldehyde gives this. Just simply remember this thing, no need to learn down anything, and that's it. क्या stupid है यार. So this is given only by aldehydes, not by the bases. Sorry, ketones. Only aldehyde, but aliphatic and aromatic both give this test. Aliphatic plus aromatic give this test. So Toland test, the aldehyde are oxidized to acids, yes. Then are reduced to alcohol, are reduced in no. Then we have Schiff's base and Schiff's reagent are two different things. And Schiff's reagent you already know. This is para-rosilin. Para-rosilin hydrochloride plus SO2 gas passed through it to make it colorless solution, which is called as Schiff's reagent, and Schiff's base is actually imine, RC. This is called as Schiff's base, imine, N-alkyl imine. So correct answer is entirely different. Then we have crotonaldehyde. Crotonic aldehyde can be easily oxidized by crotonic acid. You can easily by this 2-watt reagent. So guys, if you use Tollens reagent, it is fine. If you use alkaline KMnO4, it will disturb this. We are not supposed to do this part, so we have to ignore everything else. Tollens is far. Mild oxidizing agent has to be used. We don't need to use this strong oxidizing agent. Which gives the difference between aldehyde and ketone? All of these. They all give positive aldehydic test, not with the ketone. Aldehyde turns pink with Schiff's reagent. An unsaturated hydrocarbon X on ozolysis give A. A compound A, when warmed with ammonical silver nitrate, culture B, zup, and then sides of the test tube. The unsaturated hydrocarbon is what? So what we have to do is unsaturated hydrocarbon on ozolysis gives A, and A gives you A somewhere aldehyde. So this will not give any aldehyde. These are giving ketone, and ketone doesn't give aldehyde. This test incorrect, incorrect. And चलने गब्बरू दाना ना 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 हो गया रिता मुन्ना सीधा खड़ा. This can also give this test. What do you think? So what if I ozonolysis of this compound will give you? This produces a compound like this, HCHO. See, double we have to do. We'll put one OH and the breakage of this. Jar, I'm not getting any product out of it here. This is the product we are getting. Let me try this. C is the correct answer, not C is the correct answer. So this can be oxidized by ammonical silver test. This gives the tolerance test positive. None of the other gives this test. Only this formic acid gives the test. Next question, asked in JEE Main 2022. Check it out, this reaction, everyone. So we have a aldehyde group. Silver mirror test is given by ketone or aldehyde, only aldehyde. First compound should be this. It will stay down like this. ASCII. Let us suppose this has become COH, and then NaBH4 does not reduce anything. It will be reduced only. Aldehyde and ketone are reduced using this compound, so this will become OH, and this will be like COH. Now find the correct answer, everyone. मुन्ना दिसदा खड़ा फिर नन्द धनना आला ना हो गई हर इतना C. Do you think C is the correct answer? I find C is the correct answer. C is absolutely correct. We have next question, that the spin-only magnetic moment of the complex present in Fehling reagent. The Fehling reagent is what? Cu2 plus. Cu2 plus has what? Atomic number 29. Configuration argon 4s03d9. Number of electron unpaired is 1. So how much is the M? 1 into 1 plus 2 root 3 Bohr magneton 1.732. So nearest integer will be kya? It will be 2. What's wrong with everyone here? The spin-only magnetic moment of the complex present in Fehling's reagent. Complex present in Fehling reagent is Cu2 plus, I guess. And the spin-only magnetic moment will be what here? This is not looking correct to me. ना 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 हो गई हर इतना दर से ना खड़ा. But how, yaar? This is not correct, yaar. The correct answer should be 2 only, right? It should be 2. And I checked it. The incorrect answer is given there, even there only. So this is 2 is the correct answer. Let me just recorrect it. So guys, do attend this All India mock test JEE 2025. Examine yourself, and it's absolutely free, available. Just enroll now. Today itself, it is starting from 27th of December, that is tomorrow. So do it and boost your confidence. So next we have oxidation of ketone. Ketones, we already have covered this part, do not easily go reduction, but they go only when there is rigorous oxidation conditions are given, and under that strong oxidizing agent must be used. But the question is, which bond should be broken, 1 or 2 or 2 or 3? So guys, both products will be formed, but major product will be given by Popoff's rule. Popoff rule says that this carbonyl group will be attached with the smaller group. No need to fall down into the mechanism, just simply learn the part and move forward. We have one more oxidation of ketone called as Baeyer-Villiger oxidation. Baeyer-Villiger oxidation takes place in the presence of per acid. We use per acid. This per acid gives you the insertion mechanism and introducing an oxygen, and where does the oxygen attach with, where the oxygen should come up with. So now it's pretty easy to identify here, but like, what is it, yeah? This is the correct thing. But there's a possibility like this may go to this or this may go to this. So like, take an example. If we have this CH3 C double bond O, and we have CH2 CH3, and if we are doing the benzoic per acid, we are using, let's say we are using CH3CO, then what should be the final product? So believe me everyone, this is the correct answer. This is your major one, and this will not be the final product. Why? Now the question says why. So this is all because of the mechanism. So the mechanism involved the attack of R here. Now check it out everyone, check it out. This R group attacks here on the oxygen. So whatever the R group is having higher higher migration tendency, that will be attack on oxygen. So wherever you make the product R, C double bond O R, where we make this product, this oxygen should be directly bonded to the alkyl group, alkyl oblique hydride oblique any group with high electron density, or high migratory aptitude. That is what with the high migratory aptitude. So anyways, we'll directly jump to the question here. Some of the questions are given over here. Hydrogen has high aptitude of this high aptitude of migratory, it will be attached with oxygen, C. Here this has more aptitude, this will be attached to oxygen. Here pH has more phenyl than PHO will be the product. So that is how you could consider as Baeyer-Villiger oxidation. But again, this is how I remember, like I personally find those kind of key points out of this concept and I apply them. If you also want to feel that much comfort, don't fall in the trap of mechanism, just simply learn what is most importantly asked in this reaction. So this is what the mechanism was. The mechanism simply is attack of RC double bond O R positive electrophile, and with the formation of a molecule that is adduct of acetone and peracid. Now we have some question over here. So which of the following number of carbon atom does not remain same when carboxylic acid obtained by the oxidation? What is the question? When which of the following number of carbon atom does not remain same when carboxylic acid is obtained by oxidation? What is this nonsense question? Okay. Got it. Aldehydes are fine. Ketones will not have the same number of carbon atom. Getting me? Ketones. So let us suppose ketone, strong oxidizing agent we are using. It will give you what? CSH plus HCOH. Choose the correct statement about Baer-Villiger. Baer-Villiger says that zoop, but phenyl doesn't come over here. This is incorrect. The electron withdrawing group minus ion peroxide enhance the rate of reaction. The electron withdrawing minus ion peroxy acid. Correct. The Baer-Villiger oxidation unsymmetrical ketones regioselective. True. Guys, this order is something that we have to follow, and I think that was correct. So this is, I think all the points over here are correct. It's correct. It is also correct. It is also correct. Regioselective is this means it doesn't attack wherever it wants and giving the exact product. It is regioselective in nature. That means it only attacks where the higher magnitude, yeah, or we can say that simply that that alkyl group actually is attached to oxygen, which has higher migratory aptitude. Next is the reactions due to alpha hydrogen. So what are the alpha hydrogen? First of all, we must know alpha substitution may occur due to tautomerism, deuterium exchange, alpha halogenation, alpha alkylation, and where we have one more reaction called as haloform reaction. Anyways, we'll come to it and we'll let you know how do we do it. First of all, we already have completed this part of tautomerism. You know how tautomerism works. Tautomeric hydrogens are, this is a group, electron withdrawing group, and to electron withdrawing group we have alpha hydrogens which become acidic. They all become acidic. They can lose the electron density to the respective bond and can form enol. This is your enol tautomer. Enol exists in lesser extent until unless some aromatic compound is formed like that. So exchange of alpha hydrogen, how does it work? So racemization and DO exchange, how does it work? In the presence of water, heavy water, or a D plus over here, this reaction works like this, that this goes here, this makes O minus, an alkene will be formed, then this all the basically deuterium will be exchanged over here, minus H plus, and this is like O minus D, so OD, doubly bonded, one hydrogen, then we have D plus over here, and we have D2O. This will become this will repeatedly occur. That's in now D will come over here, and this becomes minus, and this will have D2O. D2O will occur there, and this is what deuterium and hydrogen, and then this reaction will keep on happening repetitively. It will happen repetitively, it will happen, and finally it will give you all the hydrogens, alpha hydrogens substituted from hydrogen to deuterium, and there will be a double bond. So this is called as alpha hydrogenation. and deuterium exchange process is called, this is called a deuterium exchange process. Third is called as alpha halogenation. Alpha halogenation, how does it work? When we react with bromine, Br2 and CH3COH, or Br2 and H2O. Okay, we have both of the possibilities. In the first case, we see that alpha halogen, sorry, alpha carbon and its hydrogens are acidic in nature. So let me see if the reaction is given or not. No, so I'll explain this part to you. So let's say in acidic medium, you have a reagent like this, CH3 C double bond O CS2. This hydrogen is acidic because this is alpha hydrogen. So what I'm doing is, so let's say this acidic hydrogen departs and forms an enol form. So it will be converted back into COH and then double bond and then CH2. Then we have Br2. This is electrophilic addition. Br will be getting out. It forms C wherever the stable carbocation is formed. So let's say HOBr we are reacting it with. Getting me? What I'm trying to do is, let's say this is formed this complex like this CBr with a positive charge, and the next step, let's say water is given or the acidic medium is there, it attacks on more this, it removes like this, and then it will be giving you CH3C double bond O CH2Br. So guys, every time this reaction will keep on happening and all of them can be replaced by the alpha hydrogen. So see, this is the reaction. So carbonyl compound having an alpha hydrogen undergoes halogenation reaction. Takes place in both acidic basic medium. In acidic medium, mono-halo product is formed, while in basic medium, reaction can't be stopped to mono. This will be go until final. In basic medium, it keeps on happening. Why? So I'll give you the explanation. Here, what's happening here? There we were. So we have now in basic medium, a ready-made carbanion will be there. That will promote and they will provoke this reaction to go in forward direction, creating the further compound like this. This is where we are having a hydrogen atom which is acidic, and we have a basic medium available. Base attacks here, water is eliminated out. This becomes CH3CO, CH2 negative. The CH2 negative is what? An electrophile. Basically, this CH2 attacks upon here, removes one Br minus, and then becomes what? CH3C double bond O, CH2Br. Now we also have one OH minus, another OH minus attacks over here, and same with Br2 will give you CH3 C double bond O, CBr3, like that. We have alpha alkylation method, alpha alkylation, which is another important reaction, and this reaction will be useful when you will be converting one reagent to another or will be studying about the chemical properties of these compounds. So wherever the alpha hydroxy or alpha keto or wherever alpha hydrogen is there with the C double bond O group, they become acidic. You all know, strong base is used, removed this in the form of this big attacks on Rx as a nucleophile, SN2, and then forms this compound. Which of the following can show keto-enol tautomerism? What do you think? Which can show? Do you have any alpha hydrogen? No double bond is allowed to possible in consecutive manner in cyclohexane. So this alpha hydrogen cannot go. So it is not doing any This also has this is no alpha hydrogen, and there we have alpha hydrogen, but it cannot acquire a pentavalent transition state, and due to the steric reasons this cannot do any tautomerism, steric reasons. And talking about this, yes, it can do. If one hydrogen is there, this can go. Even this is forming a very good aromatic compound like this, toluene. It does. C is the correct answer. Talking about here, it also, this doesn't go. If we, no man, there is no alpha hydrogen here. Maybe this can't. C is the correct answer. Next question. An acetone after prolonged treatment with D2. I explained you this part. Acetone is what? CH3, C double bond O, CH3, and prolonged basically presence in D2O will make the deuterium exchange reaction, and this will become CD3. CD3. What will be the product of this reaction? Na, NH2 and CH3Br. This is what? Base. This is what? Alpha hydrogen, acidic, attack over here, CH2 minus. This will attack on CH3Br, CH2C. I think B is the correct answer. That's it, everyone. That's it. Now we have come to the final part of this entire chapter. Although we took too much of our time, because this reaction of this chapter is huge, but all we derived, or all we reached to the conclusion that this reaction, these reaction can be easily understood if we have covered the prerequisites of the chapter like the previous chapters. And in previous chapters we have covered so many parts of this chapter, so many of the reactions of this chapter as well. Number one reaction. Okay, instead of wasting our time, let's move forward. Stay energetic, stay positive. Haloform reaction. We have these reactions, and then this chapter will be over in the terms of aldehyde and ketone. I'll come up with another chapter, only carboxylic acid I'll teach you. So haloform, aldol condensation, Claisen condensation, Cannizzaro, Perkin, benzoin, and then we have Wittig reaction. One by one we'll cover all of them. Number one, what is a haloform reaction? Haloform reaction is given by halogens in presence of alkali. So how this reaction works? So guys, the necessary condition is, this should be the condition, methyl keto group. If any compound has this group, it will surely give you this test. The reaction happens with the with X2 in presence of NaOH, and 4 equivalents are used here, and these are converted back into, this is becomes O minus Na plus CHX3. This is called as haloform. Now CHX3, chloroform, bromoform, iodoform, and iodoform is yellow colored PPT, and that's why iodoform tests are conducted to identify the presence of methyl keto group. Also, there could be one more group. This is CHOHCH3, methyl, and then alpha hydrogen is having this. Why does this group? Because this group can be easily oxidized. Because what we are having is the oxidizing agent only, can be easily oxidized to this. That's why this also gives you the same test. Mechanism is pretty simple, everyone. First reaction occurs in such a way that this is your acidic hydrogen. Acidic hydrogen is being taken by a base. मैं बारिश की बोली समझता नहीं था, हवाओं से मैं यूं उलझता नहीं था. Then this O minus comes here, forms an alkene. Sorry, this alkene attacks on Br2, takes one Br, removes another, and another one is removed in the case of HBr. So it is the first product. All the hydrogen are replaced by Br once this becomes the product. This is the product where 3 Br will be coming up. Where is it? This. This is the product with 3Br attached. Now it doesn't have any alpha hydrogen. It will go and attack over here nucleophilically. Then this goes like this. It comes back like this and removes the whole compound, and then it becomes CH3COCO minus. OH was already attached there, and then this is CHBr3. This is a base now. This is an acid. It will give H plus to it, and it becomes like this. And under the acidic condition, this also becomes acetic acid. So very simply, we can do the reaction. There it was written as the main reaction. Here is the mechanism. And now let's move forward and solve up with the problems. This is what compound which are used in order to carry out the reaction. The very first is active methylene group, or any halogen, any alcoholic part that can become active methylene group, that is CH3CO. Other compound which can also give haloform reactions are these: methyl keto group, methyl leaving group, and this can also be the part. Then we have 1,3-dicarbonyl test as haloform reaction. What is this 1,3-dicarbonyl gives haloform reaction test? Okay. This is called as active methylene test. Actually, 1,3-dicarbonyl. So this has become acidic hydrogen. These all acidic hydrogens will be removed like this, and the reaction, after all of them are converted back into Br, the reaction attacks over here. This entire group leaves. Not right now, but it will later on leave. What do you think? Should we move forward then? You need more clarity on this. ठहर जाओ, ये कहती है मेरी नजर. Okay, I'll explain this part. Okay, come. क्या हाल हो गया है ये मेरा, आंखें मेरी हर जगह ढूंढे तुझे बेवजह, ये मैं हूँ यार. Two equivalents I'm directly using to give an intermediate product. The next reaction of OH minus takes place on this. This departs. CBr2 C double bond of CH3. And now you all know, under the influence of next group will come and attack on this. Br, and this is a negative charge, and this will go on attack. Getting me? So this is how it will get converted, and this will be also finally converted into CH3 COH plus CHBr3. So this is how the reaction works. Two equivalent will be produced. Now some questions. We have some questions. CH3 C triple bond CH reaction with this. Hey, yaar, this is something which we already covered. Yeah. So this will give you Markovnikov's. And this will give you anti-Markovnikov's. Aldehyde and ketone are produced. See, the product A and B by differentiated by. One of them is having this methyl keto group. So methyl keto group is doing the NOI test. With this NOI, getting me? NaOH plus I2. NaOH plus I2 is haloform, iodoform test. So methyl keto only can give you this test, others cannot. Next is, what should be the structure in order to form this compound as a result? NaOCl means NaOH plus Cl2 was used here, and then followed by acidic medium. It's very easy here. There is a possibility. So there's a possibility that this compound should have been CH3. This is it. कहीं पे है रातें, कहीं पे सवेरे आवारगी, साथ मेरे. Then very important, aldol condensation. Every time question arises from here. Every time one question will be asked on aldol. Every time. These notes are self-explanatory, everyone. If you find the absence of a teacher while you are revising it, do it by your own. Believe me, you will be very much able to do it because the notes are pretty much self-explanatory. Feeling tired now. ये कहती है मेरी नज़र, रातें कहीं पे सवेरे आवारगी रही साथ मेरे. आइए. So guys, aldehyde and ketone which will be having one alpha hydrogen can go under this test in presence of dilute alkali as a catalyst, and reaction is pretty simple. So I'll explain this reaction to you. The mechanism, first of all, I want to let you know. First of all, let us know the mechanism, and then I'll explain you the shortcut to find out the product. The very first thing is basic medium is there, and we all know this is alpha hydrogen, which is acidic. It will come and attack on the alpha hydrogen. CH2 minus is something which is resonance balanced. No need to write down its resonating structure. Simply attack on the another equivalent as a nucleophile. So this is a nucleophilic addition reaction. This is actually the slow part, and this is RDS. So in RDS you will see that this has been attacked over there. This is the product is formed. This, on acquiring one H from water, has become aldol. This is called as aldol. Aldol on heating, alpha hydrogen is here. Acidic hydrogen will remove. Alpha hydrogen will remove, and OH water is eliminated out, and this is called as alpha beta unsaturated aldehyde or ketone. And what is the meaning of aldol? Aldol is actually beta hydroxy aldehyde. Beta hydroxy aldehyde, aldehyde plus all, aldol. This is called as aldol. Beta hydroxy aldehyde is aldol. So this is how very simple reaction is there. We have cross aldol also, but I can tell you in cross aldol which will be your major product. Take this example in order to know the cross aldol reaction. Let us take this example where CH3 CHO plus benzaldehyde. No, benzaldehyde can't give you, like, let us take those example where you can at least learn what product has to be formed. COCH3, and let's say simply dilute NaOH is given, and how many products can be formed has been asked. So check out the solution. So there is, like, I must give you the perfect answer. How can you make the reaction? So let us suppose, first of all, I have to make intramolecular. So I'll take this along with this. So along with this will be what? CH3C. Take this thing into this way. Let me let me explain you the shortcut first of all. Otherwise, you will not be getting the final outcome. So this was given to us. So now I'll explain how you are supposed to make the final products. So let us suppose CH3, C double bond O, H is there, and dilute NaOH is given. So the product has to be formed. So you will form CH2 double bond CH kahin pe hai raat. So this is the product that we are making here. This is not a correct product, alpha beta unsaturated. So do one thing, present them in this way, and another one in this way. This H2 and O will be eliminated out, and then you will form CH3, CH double bond, CH single bond, C double bond, and this is the final product you will get. That's how I want you to understand. And one more thing that you can do, like first you make this, and then you can make the aldol. So this is the alpha beta unsaturated aldehyde or ketone aldol. How does the aldol look like? Aldol is pretty simple. That's CH3, CH2. We have CH. Put an OH over here, then it will become CH2, and then the C double bond OH. This is your aldol. So aldol and this alpha beta unsaturated aldehyde or ketone, these are the final product. If two hydrogens are there, two alpha hydrogens are there on aldehyde or ketone, then it will go for the final alpha beta unsaturated answer. If not, then it will reach to just aldol. So talking about this example, what I'll do, I'll make simply first I'll make this compound. These are called as the self-aldol. This is the example of self-aldol. मैं लिखूं तू आ जाए, मैं बैठ लिखूं तू आ बैठे, मेरे सोने पर सर रखे तू मैं. See, so now it will eliminate out water. These are the self-aldol products. Now if you want me to make a cross-aldol, then what you need to take one of them as substrate, another one as reagent. So now I'll come to cross-aldol. First I will take this CH3, C double bond O, H, and CH3, C double bond O, PH. How it will look like? Minus water. This will be CH3, CH double bond, C, H single bond, C double bond O, PH. This is one of the product. Another could be this is PH, C double bond O, CH3. Then another one is CH3, C double bond O, H. Water eliminated out, and the product will be PH, CCH3, double bond C, H single bond CA, double bond H. So these are the cross-aldol product. This is self-aldol product. Using the shortcut only, we predict out all the reactions and all the products. Now the question is, out of these products, which will be the major? So guys, we all know that this is an SN2 reaction. So substrate should be the one. Substrate should be the one where a smaller group is there, which is easily attacked as a nucleophilic addition, and the attacking reagent should be one which should be relatively stable. So let us suppose this carbon gets a negative charge, benzene is also withdrawing it, and a minus I effect is working. So you know what? Do you know what the attack of nucleophilic is working on? This. Let me star mark it. This is the actually major product. And you can identify the major product as, check two things. One is substrate. Substrate should be the lighter one to be attacked by the base. Second one, most stable base. Whatever the base is there with a negative charge and it is relatively stable, will be attacking. So that is how we'll take cross aldol, that product as the major product. And even if you can find that the final product is relatively more stable, it's a pH over there, it will help in the extended conjugation and all. Here is the question that was asked in JEE Main 2022. So JEE Main 2020 question says that first we are using dibyl H. You all know dibyl H. What does a dibyl H do? Diisobutyl aluminum hydride only interacts with CN and will be converted into CHO. So this will be unaffected and this will become what? CHO. Then CH3CHO does what? This is an cross aldol product. So CHO is there, and there is no alpha hydrogen, so this double bond O will be used here. How? Just arrange this thing into this way and you will get your answer perfectly. Remove water. I told you this is your aldol condensation. Aldol condensation. मेरे सोने पर सर रखे तू, मैं नींद कहूँ तू सो जाए, जला एक ऐसी नज़्म कहूँ जो नज़्म कहूँ वो हो जाए. Where can you find this compound, guys? I think this is correct. B is the correct answer. So that is aldol condensation, guys. Welcome to the world of aldol condensation. We have intramolecular aldol also, in which cyclic alpha beta unsaturated is found. How? Because if there are like two keto groups or these groups are there, so one will do what? Hydrogen is removed like this, and this can attack over here. Intramolecular reaction can occur. I'll explain this part, no problem. Let us take it in our condition. What does our condition say? So our condition say that this is C double bond O. This is your CH2 group. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And there we have double bond O. Like this. So this is your so I told you this mechanism earlier. You remember? This is how we'll remove the water. And see, so double bond O is there, single bond is there. Next carbon will be connected to a double bond. So there will be a ring. This is how it is looking like. See, how did I presume it? 1, 2, 3, 4, 5, or am I missing some number of carbon atom? 1 2 3 4 5 6 7 8 9. So 1 2 3 1 2 3 4 5 6 7 8. Okay, I skipped one, mistakenly missed one. So 1 2 3 4 5 6 7 8. No यार, again missing one यार. This is how we are doing it. So how many members are there? 1 2 3 4 5 6. And to 6 member, let us suppose first one is connected to this, and then the 1 2 3 4 5 6. So 6 will be connected to CS3. So CS3 will be there. This is the final product, and this will be a double bond. So guys, this is how you can find out your final product. We have one question. In the following reaction, A will be what? A will be what? Tell me. So just break it, everyone. And wherever you are having this C, there will be used. It's we can easily predict this thing. See, H is here, double bond O is here. This might be the one which is having CH3 group here. Getting me? So we are going in reverse only. So first of all, we are following the fifth step first. The fifth step will give you one of this compound, and I guess that this compound is cyclic compound or intramolecular will be there. CH2. Then we have 1 2 3 4, and fourth will be having another CH2. So 1 CH2. This is it. This is how it look like. Fifth step we have completed. So now coming to the fourth step, we have CH2S. What used to CH2S do? O3 and CH2S. This whole thing does reductive ozonolysis. This whole thing does reductive ozonolysis. So the product of reductive ozonolysis will be what? The product of reductive ozonolysis, what do you think will be? Connect them. So this will be a 1 2 3 4 5 6. It's a then fourth step we are getting. It's a 6-membered ring, and a double bond is there. Double bond is there. That's it. 6. Then what is the not fourth, when 3 and 4 is completed now? 3 plus 4. We are going in backward direction. Then we have KOH and then alcoholic KOH. Then what could be the alcoholic KOH done to this? If this is so I think A is the correct answer. We have got enough hints here. A was initially being attacked by Br2. When Br came, then alcoholic KOH produced this one. Then we read this. This is how we are going. A is the correct answer as per me and my opinion. A is correct. See how easy. Solution is also given there. We have plenty of other questions, and I personally think that you all should do it by your own, because guys, we are running out of time and I do not have plenty of time because I have another classes to attend. So this is the homework to you. Now you do it by your own and I'll explain them in my next lecture. We have Cannizzaro reaction, another chemical reaction, very important one, Cannizzaro. So Cannizzaro reaction is those, like for those aldehyde or ketone which do not have any alpha hydrogen, so they under the presence of concentrated base oxidize and reduce, basically we can say disproportionate. This is a very important reaction called as disproportionation reaction. You all remember from the redox that one of the oxidized, one of the getting reduced. What is it happening? This is reduced, or I can simply mention here that formaldehyde going to methanol is actually reduction, and formaldehyde going to this is actually oxidation. So the same element of same compound is oxidized and reduced. This is called as disproportionation reaction. Mechanism is pretty simple. That first base will attack here, will make O minus. This O minus is highly unstable, but this doesn't have any choice because we have this in concentrated. That is why the reaction is to go in forward. O minus will come, double bond O created, H minus departs. This is called as hydride transfer, and this is the most slow step in RDS of this. So where the this will take place in the next step, this compound hydride will attack nucleophilically. This is nucleophilically. Where is it attacking with, by the way? So this is the one compound already formed. What is happening here? Double bond OH is already there. This hydride will attack on another compound, CH3O minus. So this okay, this is shown. This hydrogen will come and then this will go like this. So we will be getting one oxidized and one reduced product, which is hydrogen and O minus. This is actually the reduced product, and then the reaction in acidic medium gives you acid in this. So more importantly, you have to take care of this part, that whenever you do the cross Cannizzaro, you always remember that so let us say this is, both of them are this is heavy, this is smaller. So where can you see the attack of hydride may take place? Now what should we take care into this case? This has been oxidized. This smaller one is actually the oxidation, and why the bulkier one is undergoing reduction? Tell me. So this is all we have to decide it by the attack of first group. First group will decide all of these. That the first will take place, and mechanism has to decide it by own. So guys, this is what I'm trying to explain. Very important. This concept, try to understand. We have two compounds, CH3CHO. We have PHC double bond OH. We have HCHO, and now concentrated H2S of concentrated NaOH is given. We know that Cannizzaro has to be done, but what should be the product? A CH HCOH plus PHCH2OH, B CH3OH plus PHCOH. Now what should be the product? So now mechanism helps us to let us know what should be the major product. In this reaction, HC double bond OH is first got attacked. HC double bond OH is actually first got attacked by OH minus. So this is easier. This is easy rather than being like attacking upon over here. So this is easy. So that is how it works. The first one will be getting the lighter one is getting oxidized here. So this is like O minus, this is OH, this is H, and then this comes, and then hydride transfer takes place, and then this hydride will attack upon pH C double bond O H. This hydrogen is coming and being attacking upon here. So now guys, what you will be getting, so one of the product is HC double bond OH and another one is pH CH H O minus. So this will become CHCO minus plus pH CH2OH, and under the acidic conditions it will all be converted into. So that is why I wanted to explain you that the bulkier group will be reduced, smaller group will be oxidized. See. So who decided it? This is the deciding step. Deciding step. We also have intramolecular Canizaro, in which intramolecular Canizaro, one of them will be oxidized, another will be reduced very simply. No need to like taking unnecessarily tensions, because this is very easy part. The only difficult part was to decide among the cross Canizaro which should go oxidation, which should go reduction. That we already cleared up. Now we have some questions. So Canizaro reaction, the slowest step is attack of OH minus, no. The transfer of hydride, yes. We have major product of this reaction. Oh my god, the same question has been asked, but now we are pretty comfortable that attack of OH minus on this is easy. So that is why this will be oxidized. So HCOOH plus this will be reduced CH2OH. Where can you find this product? My life is like this. This will be a homework. Actually, I'm running out of time, so I want to go forward rather than wasting my time. We have Bachmann reagent. Bachmann reagent is very easy reaction. Bachmann reagent happens only in the case of oximes. And how it happens? We know that oximes, how oximes are formed. You remember this reaction? Water is eliminated out, oxime is formed. Then oxime, what happens here? Whatever the group is there, first of all, this water is formed. Whatever the group is there which is anti to it, only anti-periplanar alkyl group shifts. So this anti-periplanar group attack on nitrogen, and this is removed out. So what will do? It will make R and double bond C and R, and with one positive charge on carbon. Then we have attack of water. This will form this tautomerase and gives you amide. So this is imidol to amide. We are getting the final product. I think this is very easy reaction, but we will deal in one more chapter. We know amines, where we'll study this reaction in more detail. Not required, because already the detail has been revealed here. Very simple reaction is there, but the application part or the calculations or question part we'll cover in our upcoming lecture. Amines. Then we have Perkins reaction. Very easy reaction, guys. Perkins reaction is actually conducted by benzaldehyde, where benzaldehyde, under the action of acidic anhydride and sodium acetate. Remember this reaction. It is exactly the same reaction, and exactly as in, see what it will do. So I'll explain you in such a way that you will become very confident. So C double bond O is here, and show the acidic acid here. What acidic acid you have? And OAC, let us suppose here it is. So this will removed as water, exactly the same thing that we have done in earlier, and the final product will look like this. Benzene, CH double bond CH, then it will become what? C double bond O. This group eliminates out. So ACOH, it forms ACOH. And plus ACOH will be formed. ACOH, you know what is ACOH? ACOH is actually your. So that's how it works. So there was a reaction happening here. So there is a mechanism which is exactly the similar mechanism which we have seen till now, that CH3CONA, under reaction with this it gives you CH3CONA which is working like a base. This base goes and attack on the hydrogen, forming this compound acidic anhydride becomes with a negative charge. So this negatively charged thing species attack on CH3COH, forms a compound like this. This has become O minus and the chain will be like this. The next attack happens on this group and then this departs. Departs like this, O minus. So this will become what? Okay, next hydrogen is also removed in such a way that it will producing. But anyways, we know how to form the final product, so we'll just follow that. Please read it out by your own, and this is by knowing that alpha beta unsaturated acid can be get an idea of the anhydride used in Perkin reaction. This can be done by keeping the hydrogen at alpha and OH at the beta carbon, followed by breaking of alpha beta bond. One of the question is given here, which is very simple to all of us, because we know how can we prepare the product. We already know that this is nitro group attached over here, and here C double bond over CH, that will be directly connected with the acetic anhydride CH, then it will give C double bond O, and then we'll be giving OH. This is our final product. Cinnamic acid. My life is like this. Oh my god, we have done some mistake or what? Okay, CS. Okay, this was not acidic. This is actually acidic anhydride is not taken here. It's a big thing which we are taking. It's propanoic anhydride we are taking. So that is why we have committed a mistake. In fact, I have committed a mistake because the attack is happening over here. So one of the, this will become minus. So wherever you are attaching it with, will be having a CH3 group with it, and then everything will be fine. Now you see, A is the correct answer. Which of the following substrate of the reagent? Substrate should be what? Benzaldehyde. What should be, which of the following is not a substrate? So this is one of the reagent, this is also reagent, this is also reagent, but this was produced as a product. So not a reagent, it is more or less like product. The product of Perkin reaction is alpha beta unsaturated carboxylic acid. Where we are getting this here? Unsaturated acid was there, no? Beta aryl alpha beta unsaturated acid. ठीक है. This is homework will be done by you. We don't have much of time. I'll go a bit faster. Benzoin condensation is another important reaction. So that's why this chapter is huge and it has wide application. So what I'm giving you is just simple explanation behind everything. Benzoin condensation happens with benzoic acid, benzaldehyde, and benzaldehyde when heated with potassium cyanide or sodium cyanide, and it produces what? What is it here? It gives you benzoin. This reaction seems a bit interesting. I think we all should take an interest now. So let us suppose this is actually a coupling reaction between two aldehyde. So let us do the coupling, guys. So what's happening initially, we had CCH5 attacked by cyanide. So cyanohydrin will be formed. A carbon ion is formed like this, which is working as a nucleophile. Then this nucleophile attacks upon C double bond O, proton transfer occurs. Then this compound is formed like this, and now this O minus proton transfer takes place. This O minus comes and acquire, and then cyanide is removed. It is very simple that finally just try to learn out that whenever we are bringing benzaldehyde is the given and the reaction is happening, you see the reagent is very important, sodium cyanide and ETOH. So NaCN ETOH, then always understand this is the benzoin condensation reaction, and in benzoin condensation what is eliminating out? CN is eliminating out at last. Initially it is formed, so this will give you this is how it is formed. This is called as benzoin. This is called as benzylic acid rearrangement. So what is this benzylic acid rearrangement? That benzoin was given initially under acidic condition. This acquires double keto, and I got this reaction. So OH attacks on one carbon, and to become O minus. NS will come here. Benzylic, this is given, no? Here is a mechanism, check it out. So OH minus attacks upon this is the benzyl actually. Benzylic acid will be reduced. So this is something which we got earlier in basic medium. This OH is attacking, O minus is there. In RDS, pH removes out and attacks. Okay, then transfer the protons, and this is how the process. Okay, fine. We have another conversion of furyl to furylic acid in the similar mechanism. I'm star marking it, just read it out. Exactly the similar reaction is there. Aromatic aldehyde undergo condensation with an phenolic solution. KCN is called as what? Perkins. A is the correct answer. We have next reaction, Wittig reaction. So everyone, it's an important reaction. Let's just try out like how are we carrying out this reaction. So we have triphenyl alkylidene phenyl phosphorane, PPH3 double bond Cr2, simply known as phosphorane. So reaction is happening with phosphorane. What is phosphorane? Triphenyl phosphorus and doubly bonded Cr2. So this reaction with acetone, let's say this is an acetone. So does what? What is this here? Take any example here. Okay, will be converted back into, now this acetone will be converted into, okay, that's Cr2. Any example is there, yeah? We'll directly learn this reaction that okay, this is the reaction. So what it will give you that this double bond will be eliminated out. The final product you should learn that this will give you PH3P double bond O, and the both of the groups CH2 will be attached here. So it's more or less like double displacement type of reaction. Take it that way, otherwise you will be getting more confused about Wittig reaction. I'll give you one example where you will be understanding it very well. So this is the reaction CH3 C double bond O CH3, and we are about to react it with, let us suppose the reaction is happening with triphenyl phosphorus, then double bond CH2. This is called as Wittig reaction. This is called as phosphorane. This is acetone. So whenever you get the phosphorane to attack with, simply understand this is a Wittig reaction. Do the double displacement. What is the meaning of double displacement? That whatever the CH3 was there, attach it with CH2, and the phosphorus that was already connected with triphenyl will be attached now with double bond O. Simple reaction. Why to be worried when we already know the hack? So which of the following is correct statement of Wittig reaction? What do you think the correct statement about Wittig reaction? Triphenyl phosphonamide is the Wittig reaction, and triphenolamide is attacking species. It is all converted into, I think all of them are correct, guys. Yeah, all of the correct. Now this is the mechanism already explained. So last reaction is your, we have one more important reaction, do we? Okay, now I think it is over, and that's it everyone. So just that's it for the day. I hope you all have enjoyed it. The last part might have been gone in a bit faster, maybe because I had a class by 5 o'clock and I had to do it. No other option was left. But you people take care of this. And there we are having plenty of reactions, plenty of explanation, and all India mock test is going on. So now only enroll it, and do let me know if any of the doubt appears for you. Okay. So I'm here only in case of any doubt. Ask me anything if you want to ask me. So if you face any doubt, do let me know. I can reply you. I can help you out of this context. So hopefully now we are about to finish our complete organic chemistry. The only chapter which are left now, a bit part of carboxylic acid, and then amines, and then one more chapter will be left, that is biomolecules. Apart from these three, we do not have any chapter externally added in organic chemistry. So that's how we'll be finishing organic chemistry within one or couple of like weeks only. Coming week will be the, I guess, final week for this organic chemistry to finish up with. So I think nobody is having any doubt. I'm taking the doubts on the call, guys. You can ask me throughout this chapter if you have faced any regarding to your academic counseling. You want to ask me anything related to your exam. You want to ask me.